What if I told you that the solid world around you is mostly empty space, that your body never actually touches anything, and that time doesn't tick the same for everyone, including you? What if reality, as you know it, is stitched together by your brain using fragments of the past, illusions of the present, and guesses about a future that hasn't even happened yet? These aren't sci-fi theories. They're unsettling facts backed by quantum physics, relativity, and neuroscience. In the next 4 hours, we'll dive deep into the strange architecture of existence, where the rules of space, time, mass, and memory unravel beneath your feet. So if you're ready to question everything you think is solid, certain, and yours, tap like, hit subscribe, and join the journey into the invisible machinery of the universe, where even stillness is an illusion, and even you might not be who you think. You may be in a holographic universe, projected from a lower dimension. Imagine staring into a mirror that doesn't just reflect your face, but projects an entire world behind you. A mirror so vast, so intricately detailed, that it tricks you into believing what you're seeing is the original, not the copy. Now imagine that this mirror isn't made of glass, but of mathematics, information, and light. A shimmering veil stretched across the boundaries of perception, displaying a universe so real, so textured, so convincingly physical that you never question its authenticity. But what if that universe isn't as three-dimensional as it seems? What if everything you touch, feel, and experience, from the warmth of the sun, to the pull of gravity, to the memory of your first heartbreak, is actually the projected shadow of a deeper, lower dimensional reality you can't see? This is the strange and unsettling possibility suggested by the holographic principle, a mind-bending idea born not in science fiction, but in the dense equations of black hole thermodynamics and quantum gravity. It tells us that the universe we move through might not be the universe that truly is, that the three-dimensional reality we inhabit could in fact be a holographic projection cast from a two-dimensional boundary far beyond our reach. Think about that. Everything around you, this room, your body, your thoughts, could be encoded like data on a cosmic hard drive, on a distant surface you'll never touch. This isn't just a metaphor, it's a mathematical possibility supported by discoveries about black holes, which seem to store information on their surfaces rather than their interiors. Just as a hologram encodes depth on a flat surface, the universe might be doing the same, giving you the illusion of volume, of distance, of time, all while the real source code lies on a boundary beyond space itself. But if that's true, what does that make you? A 3D projection of a 2D truth, a flicker of light shaped by equations and perspective. If the brain you rely on for certainty is part of the illusion, then even your sense of self, your memories, desires, fears might be part of the projection too. The very idea blurs the lines between physics and philosophy, between scientific rigor and existential vertigo. You begin to wonder, are you seeing reality, or just a representation of it cleverly wrapped in sensory input and cognitive assumptions? What you call real may simply be what your limited instruments can detect: sight, sound, pressure, time, all tuned to a reality that's more like a cosmic simulation than a solid world. And no, this doesn't mean you're living in a video game or plugged into some machine. It means something more profound. That reality itself may be far more abstract, more mathematical, more informational than anyone ever imagined. In the same way that a photograph can capture a person's smile, but not their pain, the 3D world you see might be capturing only a slice of the real structure beneath. This isn't a new idea either. Mystics, philosophers, and poets have whispered similar suspicions for centuries. Plato's cave, Descartes' deceiver, even Eastern philosophies that speak of Maya, all hint at the possibility that what we call reality might be a convincing veil. And yet, here we are, experiencing it all as if it were solid, undeniable, true. We believe in the chair beneath us, the breath in our lungs, the pain in our chest. But physics is now telling us not to trust those feelings too much. If a holographic universe is real, then distance is an illusion, Gravity is an emergent property, and space itself is not fundamental but derived. It's as if the universe is a giant thought, encoded and rendered like software, with the screen being your perception and the hard drive lying somewhere at the edge of existence. Some physicists have even suggested that our universe is mathematically indistinguishable from a hologram, that the equations describing black holes match perfectly with those that describe our own cosmos, implying a deep, perhaps ultimate, equivalence. You may think this is far-fetched, but what's more implausible? That the universe is built on particles and fields we can't observe directly, or that it's information-based, rendered from a hidden dimension we have only just begun to notice. In this framework, even consciousness, the most intimate part of your experience, could be an emergent effect of information flow across a boundary you can't cross. The world becomes a metaphor, a dream wrapped in equations, a reflection of something more abstract and unreachable. And as you sit there, breathing in this moment, maybe you'll notice that everything around you, the textures, the sounds, the emotions, they all feel real because they were designed to. Your brain evolved not to detect truth, but to survive. And perhaps survival required embracing a convincing illusion. So when you wake up tomorrow and see sunlight streaming through the window, ask yourself, are you seeing the world or its rendering? When you close your eyes and imagine a memory, is it a real event or just the echo of light bouncing inside a cosmic mirror? You may be more than biology. You may be a ripple in a projection, a self-aware echo of something coded far beyond your comprehension. Or perhaps you're the projection's author, dreaming yourself into being. Either way, the question lingers long after the screen fades to black. If all of this is just a hologram, where do you really exist? You can't be still. Even in absolute darkness, you're always moving. Imagine standing in the absolute center of a pitch-black void. No sound, no wind, no ground beneath your feet, no up or down, no light to reflect movement, no reference to anchor your place in space. And yet, even here, in this perfect stillness, you are moving. Not metaphorically, not emotionally, but physically, undeniably, constantly, at speeds so immense and in directions so layered that your entire sense of what it means to be still collapses in on itself like a paper map in a hurricane of motion. Because even in your quietest moment, even lying motionless in bed, your body is rotating with the Earth at over 1,600 kilometers per hour, being flung through space by the planet's orbit around the Sun at roughly 107,000 kilometers per hour, which itself is hurtling around the center of the galaxy at nearly 828,000 kilometers per hour, while the entire Milky Way races toward the Andromeda Galaxy at an additional 400,000 kilometers per hour. And that's just the beginning, because all of this occurs inside a universe that is expanding, pulling galaxies away from one another, like raisins in rising dough, creating layers of drift and acceleration that make your stationary existence feel like a cosmic joke, an illusion baked into human perception by nervous systems too small to grasp the stage they're dancing on. So you sit there, breathing slowly, thinking you are still. But the truth is, you are being carried, launched, flung, bent, and stretched by gravitational tides you will never see and curvature you will never feel. Yet these forces sculpt every moment of your existence, even though your body tells you otherwise. Stillness, it turns out, is just another local illusion, a comforting lie, whispered by your vestibular system to keep your sense of balance from imploding. But at the atomic level, even that collapses because your atoms themselves are never still. Their electrons whirl around nuclei in clouds of probability, vibrating with quantum uncertainty, shifting from one energy state to another in ceaseless dances that define the boundaries of matter itself. And beneath even that, particles flicker in and out of existence, borrowing energy from the vacuum of space in compliance with Heisenberg's uncertainty principle, like ghosts popping in and out of reality before anyone can prove they were ever there at all. And suddenly, the idea of being still becomes as absurd as being dry in an ocean or silent in a symphony, because motion is not the exception, it's the rule, the default, the inescapable rhythm of existence that pulses through everything, from galaxies to cells to the spinning of subatomic quarks. And yet we measure life by how still we can become. Calm down, stay put, hold still, find peace, as if rest could ever be anything more than a temporary truce with a cosmos that refuses to stop for anyone. And this realization, this unbearable truth, wrapped in the softness of everyday perception, begins to dismantle the comfort you've built your world on. That you are grounded, anchored, still in the midst of chaos, when in fact, you are the chaos, a fragment of the great trembling, an echo of the Big Bang still rippling outward with every breath, every blink, every heartbeat synchronized with a universe that has never paused since it began. You are a mobile being on a moving rock inside a mobile galaxy suspended in an expanding fabric of space-time that has no center, no edge, and no brakes. Even your thoughts, those supposed islands of interior silence, are anything but still. Your neurons fire in electrical storms. Your brain pulses with activity. Chemicals surge and retreat, creating patterns that feel like choice, memory, feeling, all of which are grounded in movement, transition, flux. And yet you say, "I'm still," because your muscles aren't contracting, as if stillness were a lack of muscular effort rather than a delusion of scale. Even death, our last resort for peace, is not true stillness. The body decays, cells burst, atoms disperse, joining air, soil, stars, until every piece of you becomes kinetic again, re-entering the great churn of matter and motion, proving that stillness is not rest but transition, not silence but rearrangement, not the end but the remixing of form. And all of this forces you to ask, if there is no true stillness, only nested motion, then what do we mean when we seek calm, when we crave stillness, when we meditate or escape or sleep? Perhaps we are not chasing immobility, but resonance, a form of motion that aligns, that harmonizes with the greater flow, so we feel less thrown, less flung, more in sync with something older, deeper, more stable than stillness itself, something like rhythm, like gravity's lullaby, like breath, like being not at rest, but at peace with motion. And that changes everything, because suddenly the goal is not to stop moving, but to move well, to move meaningfully, to move in rhythm with what we are and where we're going. And maybe that's the deepest truth hidden beneath this paradox, that you are not meant to be still, not ever, and that every moment you pretend to be, you are still moving through time, through space, through memory and identity, shedding old versions of yourself like solar wind, brushing dust off a comet's back. And this constant movement, this endless becoming, is not a failure of presence, but its essence, not a flaw in your design, but the feature that makes you alive. So stop, waiting to be still, to arrive, to settle, because the universe you're made of never has and never will. Instead, learn to move like the stars do, not with haste, not with anxiety, but with grace, with momentum, with the quiet awareness that every part of you is part of everything else, already in motion, already connected, already becoming something new with every second that passes. You can't be still, and maybe that's not a limitation, but your most honest form of freedom. There are infinite possible pasts for this moment in quantum mechanics. Imagine trying to trace the shape of a raindrop as it ripples into a puddle, only to discover that the drop never fell in just one place, that instead it landed in 1,000 spots at once, creating overlapping waves that somehow converged into the single pattern you see now, and that everything you perceive as a straightforward history, every cause, every effect, every moment that feels like it logically led to this very second, may actually be the aftermath of an infinite number of invisible ripples, each one a different version of how things could have gone, each one as real, as valid, as mathematically plausible as the one you remember. Because in the strange, rule-bending realm of quantum mechanics, it isn't just the future that's uncertain, it's the past, too. And the idea that what happened is a fixed point behind us is, itself, an illusion we create to stay sane inside a universe that is far less linear, far less certain, and far more haunting than we were ever taught to imagine. A universe where not only can particles exist in multiple states at once, but their current state can determine which version of the past must have existed to support it, as if your present moment is not built from one singular thread of history, but from a dense braid of branching probabilities that collapsed only when you arrived here to notice them. In our day-to-day lives, we think of time as a line, past, present, future, a single thread pulled taut across memory and expectation, and we walk along it one step at a time, always moving forward, always leaving behind a past that feels as solid as the ground beneath our feet. But in the world of quantum physics, that comforting timeline is more like a fog, shifting, uncertain, retroactively rewritten by measurement and observation, where events can be entangled across time, and the very act of observing something now can dictate what its history had to have been, which leads to one of the strangest implications of all. That there is not just one past that brought you to this moment, but countless possible pasts, and which one you inherit depends not on what happened, but on what you choose to observe, measure, or remember now. This is not science fiction. This is the quantum eraser experiment, the delayed choice experiment, the baffling fact that a particle's behavior can change depending on whether you measure it after it has already acted, as if the universe rewinds its tape to match your choice, erasing some pasts and rendering others consistent with your present view, collapsing a haze of maybes into a single storyline, but only when you ask for one. Before that, the past is fluid, undefined, a vast superposition of every path the universe could have taken to get to here. And so you begin to wonder, what if this moment, the one you're living right now, is not the product of a single, inevitable sequence, but the survivor of a competition between histories, a lone reality plucked from a crowd of potentials by the razor of observation? What if the memory you hold of yesterday is not a perfect record, but the echo of the version that won out? And what if different actions now would have pulled different pasts into focus, like tuning a radio that changes? Not just the station, but the entire recording it's playing. This idea is so foreign to our classical instincts, so unsettling to our need for causality, that we resist it, we reject it, we call it philosophical or absurd. But the mathematics says otherwise, and the experiments agree. And every time we send particles through a double slit, every time we delay our measurements or entangle photons across light years, we are forced to confront the possibility that our universe does not run on a single reel of film, but a tangled mesh of potentialities, stitched together by attention, collapsing inward like a probability wave folding into itself. And we, the observers, the thinkers, the dreamers, are the ones who press play. But what does it mean to live in a world with infinite pasts? What does it do to our sense of identity, of memory, of regret? If the road behind you is not carved in stone but scribbled in pencil, waiting to be finalized by your next decision, then what does that make of guilt, of trauma, of the stories you tell yourself about how things came to be? Maybe you are not the product of a single childhood, a single heartbreak, a single mistake, but a superposition of all the ways those moments could have unfolded. And the version of you reading this now is just the one entangled with this particular narrative thread, not because it was the most real, but because it's the one you're noticing now. That changes things. That reframes memory from a camera to a canvas, from a recording to a rendering, from a fixed archive to a dynamic process of storytelling, where each recollection isn't a trip back in time, but a recalibration of which past you're choosing to embody. And suddenly, you feel the weight shift. Suddenly, you realize that the facts of your life are less factual than they are useful fictions, constructed realities that allow you to function, to persist, to make meaning, but not because they are objectively the only version of what happened. And if that's true, then you can let go of some of them. You can forgive yourself more easily. You can revise the narratives that hurt you, because in the quantum view, even the past is editable. So long as the edit aligns with a possible trajectory, so long as it doesn't violate the probability structure, so long as it could have been, it might still be, at least in the way it shapes what comes next. And this doesn't mean you should fabricate history or deny truth, but it does mean that your truth, your inner narrative, your emotional storyline, is not a slave to linearity. You are not bound to a single causality chain like a train on tracks. You are more like a surfer, choosing which wave of history to ride into the present, which version of events you will allow to define you. And that is not delusion. That is quantum realism. Even now, your neurons are firing in complex patterns built from prior inputs, but those inputs are themselves rooted in the mysterious collapse of quantum states, meaning that the electrical storm of your consciousness is not merely reacting to a static past. It is, in a very real sense, selecting from the cloud of histories that remain possible. The path that led here was not one road. It was an entire forest, and the fact that you remember a trail behind you doesn't mean the other paths never existed. They did. They do. And perhaps, in ways we can't yet measure, they still shape the wind around your footsteps. So the next time you wonder why something had to happen, why a certain memory haunts you, why your life took this turn instead of that one, remember that quantum mechanics doesn't guarantee inevitability, it offers possibility. And in that space of infinite possible pasts, you are not just a victim of causality, you are a co-author of coherence. You are the observer that gives shape to the flow. And maybe, just maybe, your attention doesn't just create the meaning of now. It whispers backwards into the void, collapsing a flickering haze of could-have-beens into a single resonant was. Particles can interfere with themselves. There's something quietly unsettling about a mirror you can't avoid. A mirror that doesn't wait for you to stand in front of it, but one that reflects you even when your back is turned, as if some deeper law insists on showing you who you are, even when you're not looking. In the world of subatomic particles, this eerie mirror takes the form of interference, not with others, but with the self. A particle, when unobserved, behaves like a wave. Not metaphorically, but literally. It doesn't travel along a single path, like a pebble skipping across a pond. Instead, it explores all possible paths at once. It splits, it spreads, it becomes a haze of possibility, an overlapping mesh of every route it could take, until the moment you try to see it. And then, in an instant, it picks one path and all the others vanish as if they never existed. But the strangest part, the part that unsettles even the most seasoned physicists, is what happens when we're not looking, when a single particle is sent through a double slit, not accompanied by others, but alone, isolated, with no chance of being bumped, influenced, or confused by a crowd. We expect it to choose one slit or the other, to act like a solid bead bouncing through a doorway, but it doesn't. Instead, it creates an interference pattern, waves cancelling and reinforcing themselves, exactly as if it had gone through both slits at the same time and interfered with itself. That's not poetic language. That's the data. A single particle, acting like a wave, going through two slits, interfering with itself, leaving behind a pattern on the detector screen that should only be possible if it was in more than one place at once. This isn't speculation. It's reproducible. It's been done with electrons, with photons, even with molecules hundreds of atoms wide. And with every experiment, the same eerie truth emerges. A particle, when unobserved, behaves like a wave of probability, existing not in a single position, but in a range of possibilities, only collapsing into a concrete location when measured. In that moment of measurement, the interference disappears. It becomes just a dot, a certainty. But until then, it's a ripple across every possible reality. It is its own echo, its own contradiction, its own mirror. And if that doesn't sound like a lesson about consciousness, identity, and the illusion of separation, then we're not paying attention. Because what else in this world behaves differently when it's being watched? What else collapses into certainty under scrutiny, but lives in plurality when left alone? The answer, disturbingly, might be us. The particle that interferes with itself challenges the very notion of individuality. It suggests that the singular is never truly singular, that identity, at its core, might be a superposition of potentials, waiting to be collapsed by attention. You are not one self. You are a field of selves. The confident version, the anxious one, the version who chose to stay, the one who left. All of them exist as overlapping waves in your quantum mind. And just like the particle, you collapse into one version only when observed, by others, by society, by memory. But in solitude, in the stillness of unobserved thought, your possibilities remain open. You can interfere with yourself. You can contradict your past, undermine your beliefs, expand in directions that seem incompatible, until someone looks and you're asked to be one thing, and suddenly the interference fades. You become a dot, a choice, a label. But the deeper truth remains, that your nature, like the particles, is fundamentally plural. And that plurality is not a defect, but a feature. It is what allows for growth, for adaptation, for change. The interference pattern is not chaos. It's a fingerprint of complexity. It means you are never limited to who you were yesterday, because you weren't a single trajectory. You were a wave of options, all equally valid, all equally real, waiting for the act of living to choose one. And even then, the others don't vanish. Not entirely. They linger, like ghosts in your decision-making. What if I had said yes? What if I had turned left? What if I hadn't given up? These are not just regrets. They are echoes. They are collapsed waves you never chose, but that shaped your pattern nonetheless. And perhaps, in ways we don't yet understand, they continue to interfere with your current path, subtly nudging, whispering, rippling beneath the surface. The particle that interferes with itself doesn't just defy our expectations, it humiliates them. It reminds us that logic, when applied to the quantum, is often inadequate. That intuition, built on the behavior of apples and cars, fails in the realm of waves and probabilities. And yet, this behavior is not confined to particles. It scales upward, not in mechanics, but in metaphor. We see it in minds that change under pressure, in personalities that fracture and recombine, in memories that shift when recalled. You are not one thing. You are many possibilities that have learned to walk in step. The illusion of unity is comforting, but it is, ultimately, an illusion. And just like the particle, you can return to interference when you're alone, when no one is watching, when no measurement is being made. That's when you become again a wave. And perhaps that's why solitude feels so expansive and scrutiny so narrow, because measurement collapses possibility, it defines, it corners. And while identity may require some collapse to function, to communicate, to connect, it should never forget its interference, its plurality, its right to exist as contradiction. That particle on the screen, flickering through two slits, is telling you something essential. It's whispering that you are never just one choice, one path, one truth. That within you, even now, are all the selves you might have been and could still become, waiting for the freedom not to be observed, not to be judged, but to ripple into existence, beautiful, chaotic, and entirely your own. You could be traveling near light speed right now and not know it. They told you motion was something you could feel. The rush of wind past your face, the trembling of the ground beneath your feet, the acceleration that pulls your body forward when a car jolts ahead. And so you believed them. You believed motion needed momentum, that speed had to be sensed to be real. But what if the very idea of stillness is an illusion? What if the ground you stand on, the chair you sit in, the room around you, and even the planet beneath your feet is already racing through space at speeds so vast, so utterly unimaginable, that no part of your body can grasp it? What if, right now, without moving a muscle, you are hurling through the cosmos at thousands, even millions, of kilometers per hour, and you don't feel it not because it isn't happening, but because everything else around you is moving with you? That's not poetic exaggeration. That's physics. Earth spins on its axis at about 1,670 kilometers per hour at the equator. It orbits the Sun at around 107,000 kilometers per hour. Our solar system itself spins around the center of the Milky Way at approximately 828,000 kilometers per hour. And the galaxy, it's moving too, careening through space at a speed we can barely comprehend, pulled by the gravity of unseen structures in a vast, expanding universe. Add it all together and you, yes, you, sitting still and scrolling through a screen, are traveling at speeds that dwarf any plane, any rocket, any human-built machine. And yet, you feel none of it. Because motion, in its purest form, is relative. Not to your senses, not to your instincts, but to other objects, other frames of reference, other observers. Einstein showed us this, not with philosophy, but with math, with a theory that rewrote the architecture of time and space. Relativity tells us that there is no absolute rest, no fixed position, no universal stillness. Everything is moving relative to something else. And once you accept this, a disturbing question arises. If motion is relative, then what does it even mean to be still? Are you ever truly at rest? Or is your entire experience of calm just a trick of context, a story told by your frame of reference, blind to the staggering velocities just beyond perception? And more than that, if you could travel near the speed of light, if somehow your frame of reference approached that cosmic limit, what would happen to you? To time? To space? You'd find that reality itself begins to bend. Clocks slow down, lengths contract, mass increases. The very fabric of your experience distorts, not in imagination, but in fact. This isn't science fiction. It's special relativity, proven, measured, confirmed again and again by particle accelerators, and atomic clocks on speeding planes and GPS satellites that wouldn't work without compensating for relativistic effects. But the real shock comes not from understanding these phenomena in theory. It comes from realizing that they apply to you right now. That even at everyday speeds, your perception of time, space, and simultaneity is shaped by motion you cannot feel. You live inside a web of frames of reference, each moving through the void, each telling a slightly different story about what's happening when, and at high enough speeds approaching light, those stories diverge dramatically. What you call now might not be now for someone else. What you see as cause might be effect in another frame. The arrow of time itself begins to blur. And perhaps most disturbing of all, if someone else were moving near light speed past you, they might see your entire life compressed, sped up, blurred into a flicker, while for you, time flows as always. Who's right? Both of you. Because in this strange universe, time is not a universal constant. It's personal, custom built for each observer, each journey, each motion, which means that the moment you accelerate, you're not just changing your position. You're bending the timeline of your life. You're altering how fast or slow the universe ages around you. That's not poetic. That's physics. And if all this feels abstract, try this. Imagine two twins. One stays on Earth. The other boards a spaceship and travels near light speed to a distant star and returns. When they reunite, they are no longer the same age. The traveler has aged less. They have skipped forward in time, not through magic, but through motion, through velocity, through the warping of time by speed. And here's the twist. This isn't some hypothetical experiment. Versions of this scenario have been tested with atomic clocks, flown around the world, and compared. The difference is tiny, nanoseconds, but it's real. And with higher speeds, it grows. Which means that, yes, motion can bend time. And no, you do not need to move under your own power to feel its effects. You could be sitting absolutely still, and yet still be a time traveler. Just by virtue of the velocities you inherit from the Earth, the Sun, the galaxy, and beyond. And once you realize this, a deeper question arises. What else do you think is fixed that might be an illusion? What other absolutes are merely context dependent? Is your personality truly consistent, or just a function of your environment, your frame of psychological reference? Are your beliefs anchored in truth, or just relative positions shaped by motion through time, through society, through memory? Physics teaches us that no observation is independent of the observer, that every measurement is colored by motion. And if that's true for light and time and mass, why not for consciousness? Why not for love, for fear, for identity? Maybe the you that exists in one frame is not the same as the you that exists in another. Maybe there are versions of you that age faster, that feel more deeply, that remember more slowly, not in metaphor, but in reality, because perception itself is not immune to motion, and the stories you tell yourself about who you are, what matters, what's real, may all be shaped by speeds you don't even sense. So yes, you could be traveling near light speed right now, and not know it, because speed is silent when everything moves together, because your body does not shake when the entire world moves in sync, because the faster you go, the less you notice, until the universe itself begins to bend. And maybe that's the lesson, that the most profound distortions of reality don't come with warnings or alarms, but with a gentle lie, the feeling that nothing is changing when in fact everything is. That stillness is a myth. That motion is constant. That truth, like time, is always in flux. And that the real miracle is not that you are moving so fast, but that you feel so completely at rest. There may be more dimensions than you can perceive. A sheet of paper believes itself to be the entirety of existence, flat, unbending, defined by length and width alone, until something pierces through it from a direction it cannot fathom, from a dimension it has no concept of, and everything it thought was the universe begins to unravel like a lie told too confidently. What if you are that sheet of paper, living your life across a surface you think is all there is, unaware that every breath, every glance, every emotion is casting shadows from higher dimensions? You were never equipped to perceive, let alone question, and your very thoughts, your sense of depth, of time, of movement, may only be cross-sections of something greater sliding through your limited perception like a four-dimensional hand brushing against a two-dimensional face. What if the real you exists partly in a direction you've never turned your head toward, never even known to turn, because your biology was built to filter out the infinite, to collapse the possibilities into something digestible and survivable, not truthful? What if your hands are only the edges of a hyperbody, your memories only the echoes of a path you walk through? A multidimensional field where past and future intertwine like strands in a braided rope, each choice a splice in a spatial fabric too vast for your neurons to comprehend. String theory, that bold and confounding tapestry of modern physics, whispers this very possibility, that beneath particles and forces and fields lie 10 or 11 dimensions, compactified, curled up like invisible threads laced through the structure of reality, vibrating in ways that define the charge of an electron, the mass of a quark, the hum of the universe itself. These dimensions, if they exist, aren't far. They're right here, between your fingers, inside your lungs, folded into the empty spaces between your thoughts, and you don't see them, not because they're distant, but because you're too entangled in the illusion of dimensional sufficiency to notice the edges curling outward into places you'll never walk. Imagine walking into a dark room with walls made of mirrors angled in just the right way so that the room looks infinite, your reflection stretching out forever, yet you're still trapped in that room. That's the kind of illusion dimensions can play, turning boundaries into infinities and making you believe that the three axes you call space and the one you call time are enough to map your reality, when in truth you're navigating with a child's crayon sketch of a world written in equations that curve and twist in dimensions far beyond your grasp. And though you measure time in seconds and distance in meters, what if the actual geometry of your existence requires units you've never invented, because you're trying to map a sphere using a ruler built for flat ground? Every dream, déjà vu, strange coincidence, or sudden intuition, what if these are not glitches in your mental software but brief bleed-throughs from nearby dimensional layers, brushing against yours like whispers through a wall too thin to remain silent forever. Quantum mechanics teases this boundary constantly, particles behaving as waves across multiple paths, interference patterns collapsing into sharp outcomes the moment you look, as if observation locks the universe into the narrow hallway of what you expect instead of what truly is. And even that hallway, this narrow beam of perception, could itself be a constraint imposed by your brain's evolutionary filter, not a feature of objective reality. Because to survive, your ancestors didn't need to understand 11 dimensions, only how to find warmth, food, and the eyes of a predator. The miracle is not that you see so much, but that you see anything at all. But now, with science and thought as your tools, you can begin peeling back the wallpaper of your reality and ask, why can't I move in that direction? Why can't I step sideways into somewhere that isn't left or right, forward or back, up or down, somewhere orthogonal to every instinct I've ever had? Perhaps because those directions aren't built into your bones, but they are into the math. In certain solutions of Einstein's field equations, space-time curls and bends in ways that allow tunnels between places and perhaps even entire realms. Wormholes, not science fiction, but science speculation, permitted by relativity, if only you had the energy of a star and the will to fold reality. And in the subatomic chaos of the quantum world, where particles pop in and out of existence, defying locality, tunneling through barriers, entangling across voids, we already see the fingerprints of a structure too strange to fit within 4 axes. Theoretical frameworks like M-theory propose that even our universe may be a 3-dimensional brain floating in a higher dimensional bulk, like a cosmic jellyfish drifting through an ocean whose depths we can't even perceive, occasionally brushing against other brains with catastrophic or creative consequences. A Big Bang, perhaps, was just one such collision. And what if dreams of parallel realities, of versions of you making different choices, aren't just narrative indulgences, but shadows cast by your hyperdimensional form, shifting ever so slightly, refracting into your limited consciousness, like flashes of lightning beyond a storm you'll never reach? This isn't mysticism, it's mathematics, it's physics, it's the collision point between what is observed and what is theorized, where truth might tremble on the edge of what can be spoken. And if you are a creature of dimensions, you are also a prisoner of them, locked into a cage whose bars you can't see because they are made of concepts, not steel. But even prisoners dream, and that dream, the dream that there is more, is the first key. Perhaps you are not just a person walking through time and space, but a wave function surfing across dimensions you cannot name, collapsing into moments that feel whole only because your mind stitches them into a single story. And if that's true, then every breath you take, every word you speak, every connection you form might ripple outward into directions that don't exist for you, but exist nonetheless. So next time you feel confined, remember, the walls are not solid. They're just limits of what you've been taught to perceive, and the true shape of your life might be a sculpture whose other sides you'll never see but always feel. Like wind brushing the edges of a soul that's more than skin and sinew, more than thoughts and time, more than anything this world alone can hold. Light takes time. What you see already happened. The light that kisses your face each morning does not belong to this moment. It's a message from the past, a silent telegram sent from the sun 8 minutes ago, traveling through the void, to find you just now, meaning every sunrise you've ever witnessed has been a ghost, a radiant echo of a world that no longer exists. And in that simple, quiet fact lies one of the most profound distortions of reality you will ever encounter. That nothing you see is real in the present. Not truly, not exactly, because vision itself is always a time machine, a delay, a recording of what once was. And the further you look, the deeper into the past you peer, until the stars you gaze upon from your rooftop are not celestial lanterns in the night, but ancient signals from long-dead suns, flares from galaxies that may no longer exist, their grandeur already gone while their light continues to arrive, like postcards from ghosts that forgot to mention they've vanished. And this truth does not stop at astronomy. It seeps into everything, every face you see, every movement you observe, every color you experience. all are delayed subtly, imperceptibly, but unavoidably by the time it takes photons to travel, to bounce off an object, to enter your eye, to hit your retina, to convert to electrical signals, to fire along the optic nerve, and only then to be interpreted by your brain, which itself is not instantaneous, but lags behind in its processing, meaning your entire perception of the world, this very moment, is already a reconstruction, a curated playback of something that just happened but is no longer happening. And the illusion of now, of being synchronized with the present, is a neurological hallucination, a survival trick that evolution refined so you wouldn't hesitate to dodge a predator or grasp a fruit. But that illusion falls apart the moment you understand light as the courier of reality and time, as the distance between events and understanding. And suddenly you realize that you have never seen your reflection as it truly is, only as it was milliseconds ago, that even the person you love sitting across from you is not fully there with you, not in the way your instincts pretend, because their image arrives just behind the moment, their expression already shifting while you interpret the one before it. Like a live broadcast with a cosmic delay no technology can erase. And if this seems negligible at earthly distances, consider what it means when you look at the moon. You're seeing it as it was 1.3 seconds ago. Or Mars, where even the fastest signals take several minutes to reach us. Or distant galaxies, whose light took billions of years to arrive, so that a single glance into deep space is not just a view of the past, but a look into a version of the universe that predates your planet, your species, your ancestors, everything you know. And this stretches further, bending into the philosophical. If all you see is delayed, then where is the present? Where is now? Does it even exist in any tangible way? Or is it always slipping through your fingers, a vanishing point you chase but never catch? And are you then just a memory machine, a creature of fragments, interpreting a universe that is always gone before you grasp it? And what does that make your choices, your emotions, your truths, if the stage upon which you experience them has already changed by the time you act? If your entire life is a dance on echoes, and your sense of immediacy is a story your mind tells to keep you sane, then is it any wonder that we feel nostalgia for things we just experienced, or regret for decisions made moments ago, when in truth the moment we regret has already decayed before we even knew it happened? And as this realization deepens, you begin to understand that perhaps the universe does not move around you, but you move through its recorded frames, your consciousness. The projector stitching old light into new meaning, framing a slideshow of photons into the illusion of continuity and time. That stubborn, invisible current might not be flowing forward at all, but simply experienced, sequentially by a brain built to sort, not understand. And you begin to ask, if what I see is always the past, then who am I really reacting to when I look at someone's smile? Who am I comforting when I see a tear fall? If reality is always one frame behind, then is love, fear, beauty itself just the appreciation of the irreversible, the poetry of something that was, not is? And doesn't this make every second holy because it is a vanishing relic the moment it's born? And perhaps this is the true miracle. Not that light takes time, but that it arrives at all, that across the unfathomable abyss of space and the biological fog of perception, we can still see each other, still feel, still connect, however faint, however late. And maybe, just maybe, what matters is not the lateness of light, but that it was ever sent at all. A flicker of existence that traveled for ages to say, I was here. Space can expand faster than light, without breaking physics. Imagine blowing up a balloon, not just any balloon, but one that stretches out into every direction, without edges or a center, without anything outside it to define where it begins or ends. Now imagine that this balloon isn't floating in space. It is space. The surface you're inflating isn't moving through a surrounding environment, but generating that environment as it grows. You might expect that there should be a limit to how fast the surface of that balloon can stretch. After all, nothing can travel faster than the speed of light, right? But what if I told you that the expansion of the balloon isn't limited by that speed limit at all, not because the universe is breaking the rules of physics, but because it's playing a different game entirely. You see, when we talk about the speed of light, we're referring to a cosmic speed cap placed on motion through space, not motion of space itself. Light moves at 299,792, 458 meters per second, an unbreakable barrier for anything with mass. But space? Space can cheat. Space doesn't need to move through anything. It stretches, expands, grows. Not like an object pushing forward, but like a canvas painting more of itself into existence. Like a dream unspooling into reality, without any constraint of terrain or resistance. During the earliest moments of the universe, the period known as cosmic inflation, space expanded so fast that two regions once touching were torn apart faster than light could have ever traveled between them. Galaxies today are still being flung apart, not because they're zooming through the cosmos at superluminal speeds, but because the very fabric between them is inflating, like new terrain unrolling beneath their feet. And the further out you look, the faster those galaxies seem to recede, not because they're breaking physics, but because the ruler you're measuring with is being stretched as you use it. It's as if you're on an escalator that's lengthening faster than your steps. No matter how fast you try to close the gap, the floor beneath you is racing away, creating distance not by motion, but by transformation. This isn't just poetic metaphor, it's cold, hard cosmology. The expansion of the universe is governed not by Newtonian momentum, but by Einstein's general relativity, which allows for space-time itself to morph, flex, and extend in response to energy and mass. This means space can, and does, expand faster than the speed of light. And this behavior doesn't violate relativity because information isn't being transmitted faster than light from one point to another. There's no signal, no messenger particle, no object outrunning a photon. There's just geometry unfolding into new patterns. Think of it like inflating a piece of graph paper. If the grid itself expands, then all the dots get farther apart, even though none of them actually move. This is how galaxies recede from us at apparent faster-than-light speeds, not by motion, but by metric expansion. And while this idea might sound esoteric, it has very real consequences. There are galaxies, today, visible through our deepest telescopes, that are already too far away for their light to ever reach us again. The light they emitted billions of years ago is just now brushing against our detectors, but any light they emit from this moment forward will never catch up. They're already past the cosmic horizon, sailing beyond the event edge of our visible universe, not into darkness, but into isolation. In time, more and more of the universe will drift beyond this horizon. 1 trillion years from now, if any conscious being still looks to the skies, they'll see nothing but darkness. All the galaxies we see today will be gone, not because they've died, but because the stretching of space has outrun the light trying to reach them. Cosmic loneliness, dictated not by destruction, but by distance. And yet, this very process is what allowed structure to form in the first place. Without inflation, the universe would have remained smooth and featureless. No galaxies, no stars, no you. Expansion isn't just a stretching, it's a sculpting. It's what smoothed the creases of chaos into coherent form, cooled the fire of the Big Bang into the quiet elegance of atoms, and spread the raw materials of life across the fabric of time. But it also hides mysteries. What causes space to expand? Why does it do so unevenly? What is this dark energy, the mysterious force accelerating the universe's growth? No one knows. It's like watching the walls of a room expand outward while trying to guess what's pushing them, and realizing you're inside the wall itself. You are part of this inflating balloon. Every atom in your body is riding the wave of expansion, tethered not to where it came from, but to where the universe lets it go. And here's the strangest part. There is no center. Every point in the universe sees itself as the middle of expansion because the balloon analogy is misleading in one crucial way. The universe isn't expanding into anything. There is no outside, just more inside. Every galaxy is carried away from every other, like raisins in rising dough, and every observer sees all others receding equally and symmetrically. That's not a trick of perception. It's baked into the structure of space-time itself. And if this feels unsettling, perhaps that's because our minds were never evolved to understand a cosmos that doesn't fit inside our metaphors. We like to think in terms of movement, not metric change. We're wired to understand speed, not scale transformation. But nature doesn't care about our intuitions. It does what it does, and dares us to catch up. And so, while nothing can travel through space faster than light, the stage itself, the arena of all motion, can stretch without bound. It's not breaking the rules, it's redefining the playing field. And maybe that's the most humbling realization of all, that the universe isn't a thing moving through time, but a process rewriting its own dimensions, unfolding like thought from a mind we can barely glimpse. So the next time you look up and wonder how far away that galaxy is, remember, its distance isn't fixed. It's a living question, one that keeps receding the moment you try to answer it. Not because you're too slow, but because reality itself keeps moving the goalposts. In this cosmos, stillness is an illusion, direction is a relative story, and distance is a moving target. And maybe the final question isn't how far space can expand, or how fast, but whether there's a limit to how much we're allowed to understand before the very rules shift beneath our comprehension. And the universe, smiling in silence, quietly outruns us again. The vacuum is never truly empty. It's a sea of activity. Imagine standing alone in a vast, pitch-black cathedral of silence, where not a single sound vibrates, not a single particle seems to stir, and every breath feels swallowed by the immensity of nothingness surrounding you, a stillness so profound it seems sacred, like existence itself has stopped to listen. You might think, in this place, you found pure emptiness, a vacuum untouched by motion or matter or memory. But what if I told you that this apparent silence is a lie, that beneath this illusion of stillness roars a storm of relentless, invisible energy, a sea of creation and destruction so violent and unceasing that if you could truly see it, you'd never again believe in the idea of nothing, because in the language of physics, emptiness is never empty. The vacuum, that supposed nothingness between stars, between atoms, even between the subatomic particles inside your body, is in fact a swirling quantum foam, an ocean of particles, bursting into existence and vanishing within fractions of a second, like sparks from a fire you didn't know was burning. It's a place where virtual particles, the ghostly twins of matter and antimatter, appear spontaneously, live brief and paradoxical lives, and then annihilate each other into pure energy, all without violating the laws of physics. How? Because quantum uncertainty demands it. Because the vacuum isn't a passive absence, but an active field, pregnant with potential, trembling with fluctuations so small, so fast, and so beyond perception that what we call empty space is more alive than any still lake or silent forest you've ever stood in. Every point in space, no matter how desolate it may seem, seethes with this hidden drama, a chaotic ballet choreographed by the quantum fields that underlie reality. These fields aren't things in space. They are space. They're the fabric from which all particles emerge, the invisible loom on which matter is woven. Even in absolute zero, where all thermal motion ceases, this quantum churn doesn't stop. In fact, it's there most starkly, whispering that nothing is ever truly still, and nowhere is ever truly empty. And it's not just theoretical poetry, it's been measured. The Casimir effect, a haunting demonstration of this truth, shows that two uncharged metal plates placed a tiny distance apart in a vacuum will feel a force pushing them together. Not because of any classical attraction, but because the vacuum energy between them is literally different from the vacuum outside. It's as if the space between the plates has less nothingness than the space outside them, and the universe, allergic to imbalance, tries to equalize the pressure of this unseen storm. What's more, this vacuum energy isn't just a curious anomaly. It's possibly the most dominant force in the cosmos. We call it dark energy, but that's just another name for our ignorance. Whatever it is, it's driving the acceleration of the universe's expansion, pulling galaxies apart with more force than gravity can contain. So the empty space between galaxies is expanding not because of mass, but because of the energy of nothing. The vacuum is not the absence of being. It's the engine of becoming. And yet, this realization doesn't only rewrite physics, it rewires our intuition. It asks us to look at silence not as the absence of sound, but as the presence of deeper frequencies. It urges us to rethink rest as a disguised motion, peace as a hidden pulse. The same principle applies to your body. Every atom within you, though seemingly stable, is held together by the constant exchange of virtual particles. The electromagnetic field that binds electrons to nuclei is buzzing with these quantum fluctuations. The strong force that holds quarks together inside protons and neutrons is mediated by gluons, particles that themselves flicker in and out of the vacuum. In other words, you are not built from solid, static parts, but from probabilities, potentials, and patterns emerging from a restless void. You are a ripple on a field that never rests. Even light, the clean, graceful carrier of information across space, is a vibration of the electromagnetic field, a rhythm drawn from the symphony of the vacuum. What we perceive as light is space shaking itself into visibility. And the implications go further. Hawking radiation, the process by which black holes evaporate, occurs because quantum fluctuations near the event horizon occasionally allow one virtual particle to escape while its partner is pulled in, robbing the black hole of mass drip by drip until it dies not with a bang, but with a whisper. Even death in the universe, it seems, is orchestrated by the vacuum's silent hand. So what does it mean to live in a universe where the void is not a graveyard, but a womb? What does it say about our definitions of fullness and emptiness, of noise and quiet, of being and not being? Philosophically, it's a revelation as much as it is a contradiction. It suggests that beneath what we call stillness lies the blueprint of all motion, that behind what we call absence is the scaffolding of every possible presence. The vacuum doesn't sit passively waiting for matter to cross it. It builds the stage, the script, and the actors. And this has psychological echoes too. How many times have you felt hollow, like there was nothing inside you worth showing? How often have you looked at your own mind and feared that its silence meant insignificance? But if the vacuum teaches us anything, it's that the most profound activity can happen beneath the surface of stillness. That what appears empty might be more alive than anything screaming for attention. That even the quietest moment, even the loneliest void, holds the power to shape galaxies. And if that's true for the cosmos, why not for you? Perhaps your most creative forces stir when you feel most empty. Perhaps your mind, like the vacuum, is never truly still. It's simply forming the conditions for something invisible, something momentous to emerge. And maybe meaning isn't born from loudness or certainty, but from the quiet pressure of potential, the tension between what is and what could be. In the end, the vacuum whispers a kind of truth too vast for our senses and too subtle for our instruments, that nothingness is an illusion and silence is a song we haven't yet learned to hear. So the next time you sit in a quiet room and feel the weight of stillness pressing in, remember, you're not surrounded by emptiness. You're floating in a quantum ocean, a living field of endless possibility, where the very absence of matter is teeming with the blueprint of all existence. And maybe, just maybe, that's where the most important things are born. Not in noise, not in form, but in the invisible hum of what we once mistook for nothing. The universe has no edge, but it's still expanding. Imagine sailing across a vast ocean with no land in sight, no stars overhead, and no compass to guide you, just infinite waves beneath your feet, and a horizon that keeps moving away no matter how far you go. Now imagine that this ocean isn't made of water, but of space itself, and that the ship you're on is not moving through this space. It's carried by it, part of the ocean's surface, stretching as it flows, sailing not toward anything, but away from everything else. This is the universe you live in. Not a static container with walls and borders, but a boundless, self-expanding continuum that defies every instinct you've inherited from living in a world with edges, walls, doors and ceilings. You've been taught to believe that everything must have a beginning, a middle, and an end, a book, a road, a room, a body. But the universe laughs gently at those assumptions, because while it is expanding, becoming larger every moment, it does not do so from a central point, and it does not spread into an outer void. There is no outside. There is no center. There is no edge. It is not exploding into space. It is creating space as it goes. The universe is not growing in anything. It is growing as everything. And if that sounds like a contradiction, it's only because your mind was never meant to comprehend something so alien. When cosmologists describe this expansion, they speak not of things moving through space, but of space itself expanding. Every galaxy is receding from every other galaxy, not because they are flying apart like shrapnel from an explosion, but because the very space between them is stretching, like dots on an inflating balloon. But here's the twist. That balloon analogy, it's only half true and dangerously misleading. Because the balloon has an edge. It exists in a higher dimensional space, but the real universe doesn't. It has no skin, no exterior, no boundary you could approach and say, this is where the universe ends. You can travel forever and never arrive at a wall because space doesn't have borders. It curves. In fact, depending on its geometry, space might be flat and infinite, or curved and finite like the surface of a sphere, looping back on itself. But even if it's finite in volume, it still doesn't have an edge, because every point leads seamlessly into the next. It's like living on the surface of the Earth. You can walk in any direction and eventually come full circle, but you'll never fall off a cliff labeled end of world. Now magnify that to 3 dimensions, and you'll begin to grasp the strange, edgeless architecture of cosmic reality. And here lies the real enigma. If the universe has no edge, what does it mean to say that it's expanding? What is growing, and into what? The answer is that space is not stretching into pre-existing emptiness. It's not pushing aside a cosmic curtain to make room for more stars. Instead, it's the metric of space itself, the ruler by which we measure distance, that is changing. 2 galaxies that were once 1 billion light-years apart may now be more than twice that distance, not because either moved through space, but because the space between them grew. Imagine standing on an infinite rubber sheet with another person a few steps away. You don't walk, they don't walk, but the rubber stretches, and now you're farther apart. Not because you moved, but because the ground moved beneath you. That's how the universe expands, from within, not into. And yet this expansion has consequences so real, so measurable, that entire galaxies vanish from view. Because light, the messenger of the cosmos, travels at a fixed speed. And when space expands faster than that speed, light can never bridge the growing gap. There are galaxies today that will never again send us their light. Not because they're hidden, but because they've passed beyond the cosmological horizon, carried away by the relentless swelling of space. And this isn't just a feature of the distant cosmos. It's happening everywhere, all the time, even between the atoms in your body. Though the effect is minuscule at small scales, held in check by gravity and electromagnetism, the expansion of the universe is not selective. It affects everything. It's the quiet backdrop to every moment of your life. So why does it expand? And why at this rate? No one fully knows. What we do know is that dark energy, a mysterious pressure woven into the vacuum itself, is accelerating this expansion, as if the fabric of space wants to pull itself apart. The universe isn't coasting, it's racing. And the more it grows, the faster it grows, leading to a future where more and more of existence slips beyond our reach. In trillions of years, the night sky may go dark. Not because the stars have died, but because their light can no longer catch us. Civilizations that arise in that era will look to the heavens and see only blackness, unaware that they are adrift in a much larger cosmos now hidden behind a horizon that can never be crossed. And yet, despite this expansion, the universe remains edgeless. There will never be a frontier. No voyager will ever plant a flag on the rim of creation and look into the void beyond. because there is no beyond. The universe is all there is, not in the poetic sense, but in the literal, mathematical, topological sense. It is unbounded, and that unboundedness is not a failure of our understanding. It is a property of reality itself, a property that forces us to rethink what it means to move, to grow, to exist. Expansion without edge challenges everything your senses tell you. You are used to rooms with corners, maps with borders, stories with final pages. But the universe offers no such comfort. It is a tale without a last sentence, a canvas that paints more of itself every time you blink. And in this structure, you are not outside looking in. You are part of the growth, a participant in the story of space unfolding. Every breath you take is stretched by expansion. Every star you see is redshifted by distance. You are not on the edge of anything. You are floating inside the infinite, carried by the current of something that has no banks. And this realization doesn't just stretch your mind, it redefines your place. You are not navigating a cosmos like a ship in a sea. You are the sea, learning to notice its own waves. You are a ripple in the boundless, folding back on itself, sensing the texture of space through thought, through language, through wonder. And so the next time you look up at the sky and wonder where it ends, remember, it doesn't. The stars do not shine against a backdrop of emptiness. They shine within a field that has no outside, no perimeter, no frame. You are not surrounded by a boundary. You are immersed in a process, and that process, expansion without limit, growth without direction, is not something happening to the universe. It is the universe. And maybe, just maybe, the most profound truth of all is that the more you try to find the edge, the more you realize the edge was a myth, an echo of smaller truths, of childhood walls and city limits and terminal stations. The cosmos knows nothing of edges. It knows only of becoming. The same atom can exist in two different places. Imagine holding a single coin between your fingers, smooth, cool, familiar, and flipping it into the air, watching it spin and shimmer as it arcs through space. Now imagine that before it lands, you're told that the coin is both heads and tails at once, that until your eyes force it into a decision, it exists in a kind of shimmering maybe, a suspended bothness. You might dismiss it as a trick, a metaphor, a thought experiment gone too far. But now imagine that it isn't a coin at all. It's an atom, a particle of matter, a building block of your reality. And not only is it in two states, it's in two places. The same particle, one identity, one source, simultaneously existing here and there, like a ghost that forgot to choose which room to haunt. That's not poetic exaggeration, that's quantum mechanics. Welcome to the impossible truth that the very atoms from which you are built, the electrons zipping through your neurons, the quarks in your blood, the photons hitting your retina, do not behave like solid, punctual, baseball-like objects. They behave like waves, but not like waves on a pond that exist in one place and time. Quantum waves are probability fields, mathematical descriptions of where a particle might be. And until you measure that particle, it is not merely unknown where it is not anywhere in particular. It is many places at once. The same atom can, quite literally, be in two locations simultaneously. And when we measure it, we collapse that wave of possibility into a single actuality. It's not that we find out where it was, it's that our very act of observation decides where it is. The phenomenon is called quantum superposition, and it's not just a fringe curiosity, it's the bedrock of how our universe operates at the smallest scales. The famous double-slit experiment is the gateway drug to this madness. Fire a single electron at a barrier with two slits, and if you're not watching, the electron acts like a wave. It goes through both slits, interferes with itself, and lands on a detector screen in a pattern that suggests it's been everywhere at once. But the moment you add a detector to see which slit it actually went through, the interference vanishes. The electron chooses a path. The wave becomes a particle. It's as if the universe doesn't commit to a version of reality until you demand an answer. But it gets stranger. In carefully controlled experiments, done not by philosophers but by physicists with lasers and vacuum chambers, we've taken entire atoms, not just electrons, and place them in a superposition of two different locations. We've done it with molecules too, some made of dozens of atoms, and in theory, nothing stops us from doing it with larger objects, except practicality. The math doesn't blink, it says yes. Reality allows it. The universe beneath the surface is a blur, and the only reason you don't see a chair existing in two rooms at once is because chairs are made of trillions of atoms, and the more atoms involved, the more they bump into each other, interact with their environment, and collapse their possibilities into concrete facts. This is decoherence, and it's the reason the quantum weirdness fades as you zoom out, but it never truly disappears. And so we face the paradox. How can something be in two places at once? What does location even mean in a world where existence is probabilistic? When we say an atom is in two places, we mean that its wave function, a mathematical object that encodes all possible states, has non-zero values in those two regions. Until we observe it, we must treat it as both, not as a lack of knowledge, but as a fundamental feature of reality. And this is not an artifact of bad instruments or blurry data. It's baked into the most accurate physical theory humanity has ever constructed. Quantum electrodynamics, built on these bizarre assumptions, has predictions that match experiment to more than 12 decimal places. This isn't mysticism, it's math. And if you're still clinging to intuition, if your brain is whispering, that doesn't make sense, you're not wrong. It doesn't make sense, not to a mind evolved to throw spears and make fire. Evolution built us to track lions on the savannah, not electrons in a vacuum. Our brains are Newtonian, linear, local. But the universe isn't. At the quantum level, it's non-local, reversible, probabilistic, and, most hauntingly, contextual. It doesn't tell you what is, it tells you what could be. And until you look, everything is what it could be. This leads to breathtaking questions. If a single atom can exist in two places, what does that say about you, who are made of atoms? Is your consciousness built on the superposition of states? Are your decisions, your thoughts, your memories floating in a quantum cloud, waiting to collapse into you? Could there be many versions of you, all possible, all real, waiting for one to be chosen? Some interpretations of quantum mechanics, like the many worlds interpretation, say yes, that every time a particle chooses a path, the universe branches, that every possibility is realized in a separate world, that there are infinite yous, each living out a different quantum possibility. In one, you stayed. In another, you left. In one, you spoke. In another, you fell silent. It's a theory that rescues determinism, but at the cost of birthing an uncountable number of realities with every heartbeat. Others argue for objective collapse, suggesting the wave function is real but unstable, and that some universal threshold forces a choice. Still others believe in pilot wave theory, where the particle has a hidden guide, a deterministic whisper threading it through the chaos. But no matter the interpretation, the experimental result remains. The same atom can exist in two places, and not just briefly. We've held them there, entangled them, shifted them, measured their interference. These are not accidents. These are glimpses behind the curtain. And if this is true at the smallest scales, we must ask, where does the quantum world end and the classical world begin? Or is the classical world just an illusion of scale, a quantum fog rendered opaque by complexity? It may well be that everything, from stars to thoughts to love, is built on the same shimmer, the same unchosen potential. That reality is a dance between possibility and choice, and that what we call real is simply what we've observed enough times to believe. So the next time you place your hand on a wall, remember, the atoms in your skin are not stationary. They are smeared out clouds of probability, fuzzed into location by entanglement and interaction. The wall is not a solid barrier. It is a buzzing field of ghosts, stabilized only by the overwhelming weight of collective measurement. And deep within, some of those atoms may, even now, be whispering of other places, other paths, other yous. And maybe that's the true miracle. Not that reality is weird, but that your mind, against all odds, can touch it. The same laws of physics apply everywhere, but that might not always be true. Imagine being handed a single elegant book with the title The Laws of Everything, told that its pages contain the unchanging rules by which all matter moves, all light bends, all stars burn, and all atoms bind. You open its first chapter and find Newton's precision, Einstein's curvature, Schrödinger's shadows, Maxwell's elegance, Planck's whispers, and you're told that wherever you go, in the cosmos, no matter the distance or direction, these pages hold true. Drop a stone here or on the edge of a galaxy, and it will fall the same way. Split light through a prism on Earth or on a planet circling a dying sun, and the spectrum will spill in identical colors. In this grand narrative of physics, uniformity is the promise, a universal consistency that allows us to build rockets, decode starlight, and trust that what we discover in one lab holds true for all of space and time. This principle, known as the cosmological principle, whispers that the universe is homogeneous and isotropic when viewed on a large enough scale, that physics has no preferred location, no hidden corners, no secret dialects of gravity or electromagnetism in distant realms. It's comforting, isn't it? Like discovering that the language of reality is the same in every village, every city, every hidden continent of existence. But what if that comfort is built on an assumption? What if, in the deep folds of space or in the first silent seconds of the universe, the rules changed, even slightly? What if the constants we treat as immutable, like the speed of light, the strength of gravity, the charge of the electron, are not as constant as we believe? What if the laws of physics are local customs, not universal mandates? Because beneath the veneer of uniformity lies a tension, a quiet whisper of doubt echoed in data, in mathematics, in cosmic mysteries that refuse to fully resolve. Consider the fine structure constant, that dimensionless number, approximately 1/37, that governs the strength of electromagnetic interaction. It's woven into everything from atomic spectra to the fusion in stars. It has no units, it simply is. And yet, some astrophysical observations suggest it might have varied ever, so slightly over billions of years and light years, not enough to rewrite chemistry, but enough to question everything. If a constant isn't constant, then what else can shift? And how would we know? Look further, to the cosmic microwave background, that ancient afterglow of the Big Bang, a canvas painted with the earliest whispers of time. It should be smooth, symmetric, isotropic. And mostly it is, but not entirely. Subtle anomalies, like the axis of evil, a strange alignment in the background radiation, hint that the universe may have preferred directions after all. A cosmic up and down that violates the assumption of symmetry. That's not supposed to happen. The math didn't predict it. The standard model didn't account for it. But the universe doesn't ask for our permission to be strange. Then there's the accelerating expansion of the universe, driven by what we call dark energy, a placeholder name for our ignorance. According to Einstein's equations, the universe should decelerate unless something is counteracting gravity. But in 1998, we found out it's not slowing down, it's speeding up. And the rate at which it accelerates seems to be different depending on how we measure it. The Hubble tension, as it's now called, is the discrepancy between the expansion rate derived from nearby observations versus distant, early universe data. The same laws should give the same answer, but they don't. It's as if the universe remembers a different rulebook depending on when or where you ask. And then there's quantum mechanics, a framework so precise it can predict the energy levels of an electron in a hydrogen atom to a degree unmatched in science. Yet, it is fundamentally probabilistic, non-deterministic, and seemingly incompatible with the geometry of space-time that Einstein gave us. For nearly a century, physicists have tried to unify quantum mechanics with general relativity, to write a single law book, a theory of everything. And so far, we've failed. Why? Maybe because we assume there is one single book, Maybe reality is not under obligation to conform to a unified, consistent set of laws that apply identically everywhere. Maybe physics is emergent, not fundamental. Some physicists entertain this radical idea, that the laws of physics are not written into the fabric of reality like commandments, but are instead evolving, shaped by deeper principles we haven't yet discovered. Maybe different regions of the early universe had slightly different laws, and only those regions where stable structures could form survived long enough to evolve observers like us. This is known as cosmological natural selection, an idea that parallels Darwinian evolution, but on a cosmic scale. Universes are born with random parameters. Those with laws that allow complexity survive, and we find ourselves in one of those survivors, thinking its laws are sacred when they may just be lucky. Even more unnerving is the possibility posed by string theory and the idea of a multiverse, that our universe is just one bubble in a vast froth of universes, each with different physical laws. In some, gravity may be too strong for stars to form. In others, no chemistry, no atoms, no structure at all. Our laws are not universal in that case. They're local weather, not global climate. And we only think they're everywhere the same, because we can't leave our bubble to compare. It's the cosmic equivalent of assuming the entire Earth is desert because you were born in the Sahara. These ideas, once fringe, are now taken seriously in the most elite corners of theoretical physics. And if they are true, then our understanding of truth itself changes, because science has always thrived on the idea that nature is reproducible, that a result obtained in one place will hold in another. That assumption allowed us to build telescopes, accelerators, and entire cosmological models. But if the universe has regions, either across space or time, where different rules apply, then reproducibility becomes local, truth becomes regional, and understanding becomes conditional. This doesn't render science meaningless. It makes it more precious. It reminds us that our models are not mirrors but maps, drawn with ink made of light and inference and limited perspective. We are not discovering eternal truths. We are uncovering contingent patterns. And maybe that's more beautiful, because it means the universe is not a machine grinding along on immutable rails, but a living, breathing structure with gradients, exceptions, and evolution. It means the story of physics is not finished. It's not even fully begun. Every theory we cherish, every elegant equation we etch into marble, is a chapter, not the epilogue. The fact that EMC2 holds in this corner of reality does not guarantee it echoes in all others. The beauty of Maxwell's equations, the triumph of quantum field theory, the elegance of relativity, these may be local symmetries, the way autumn colors paint only certain forests, while others remain green. And perhaps that's what consciousness is. Not an accident of physics, but a mirror for it. A phenomenon that can only emerge where laws are just right, balanced on the knife's edge between chaos and sterility. Your thoughts, your breath, your awareness of this sentence, they exist because somewhere, somehow, the laws settled into a configuration that permits you. But if the laws are not fixed, then identity itself becomes fragile. If the universe is not uniform, then meaning is not static. We are not products of inevitability. We are children of chance, of context, of conditions that might not hold forever. So the next time you drop a ball and watch it fall, know that you're not just witnessing gravity, you're witnessing agreement, an unspoken pact between reality and reason, a coincidence of consistency, and maybe, somewhere, somewhen, that same ball would rise instead, tracing a trajectory dictated by laws we've never imagined. And in that moment, you might wonder, are we privileged to live in a universe with knowable laws? Or are we imprisoned by the illusion of constancy, blind to the possibility that truth itself can change its form depending on where you look? Maybe the greatest assumption in all of physics isn't that the universe can be understood, but that it should behave the same way everywhere. And maybe one day, we'll learn that the laws we hold sacred are just one dialect in a cosmic language, far more vast than any book could hope to contain. You age slower the closer you are to a massive object. Imagine holding an hourglass in your hand, watching the sand fall grain by grain, counting each second like a gentle heartbeat of time itself. Now imagine placing that same hourglass at the base of a mountain, while another identical one rests at the summit. You wait, patient, unwavering. When you bring them back together, something impossible has happened. The two hourglasses disagree. One has aged a little less. Time, which we thought was sacred, absolute, universal, has betrayed us. Or rather, revealed its secret. It can be stretched. It can be slowed. It can favor one place over another. And more disturbingly, it can treat two people standing mere kilometers apart as if they are not quite in the same reality. Because time, as Einstein discovered, is not a background canvas against which the events of the universe are painted. It is a participant, a dancer, a malleable flow affected by gravity itself. And gravity is not merely a force, it is curvature. The Earth doesn't pull you down, it bends the space-time around you, and your body follows the path carved by that bend. And here's where it becomes strange. The stronger the gravity, the slower time flows. Not metaphorically, not in illusion, but in real, measurable, testable fact. Time ticks slower in deeper gravitational wells. That means your head, perched high above your feet, is aging faster than your toes. A clock on a plane races ahead of a clock on the ground. And the closer you get to a massive object, a planet, a star, a black hole, the more pronounced this effect becomes. Near a neutron star, seconds can dilate into hours. Near a black hole, time itself nearly halts. And this isn't theoretical. We've tested it with atomic clocks, the most precise instruments humanity has ever created, so accurate they wouldn't gain or lose a second in billions of years. Place one at sea level and another on a mountain, and they will diverge. GPS. Satellites must constantly adjust their onboard clocks to account for gravitational time dilation. Otherwise, your phone's navigation would drift by kilometers each day. In the language of general relativity, gravity and time are inseparable. Mass bends the fabric of space-time, and that bend stretches time itself. It's like resting on a rubber sheet that dips beneath you. The deeper the dip, the slower the rhythm of everything within it. But what does it mean to age slower? Does your heart beat slow? Do your thoughts drift more languidly? No, your biology proceeds as usual, completely unaware. To you, time is time. But to someone far away, someone watching from a weaker gravity field, your seconds appear longer, your life drags slightly, not enough to notice in daily life, but in extreme environments it adds up. If you lived your entire life at the bottom of a deep gravitational well, while your twin lived on a high-altitude plateau, you would be younger, not figuratively, not in the poetic sense. In raw, empirical years, you would have experienced less time. And this warping isn't limited to gravity. It also happens with motion. The faster you move, the slower time flows for you, from the perspective of others. It's called time dilation, and it's why astronauts returning from long missions have aged milliseconds less than their Earthbound counterparts. This has been verified again and again. Muons, subatomic particles created by cosmic rays in the upper atmosphere, should decay before reaching Earth's surface, but because they travel so fast, their internal clocks slow, and they survive longer than they should. Motion and gravity, two sides of the same coin, both distort the flow of time. And what's remarkable is that Einstein's theory predicted all of this over a century ago, with no direct evidence at the time. He simply followed the math, followed the logic, followed the idea that space and time are not separate, but united in a single fabric that bends. But what does this mean for you, a being made not of equations, but of memory and breath and heartbeat? It means your life is not ticking at a universal pace. It means your time is local, tied to where you are and how you move. It means that age is relative, not only to experiences, but to geography and velocity. It means that if you could live near the edge of a black hole for decades, safely, hypothetically, and then return to Earth, the world you left might have passed through centuries. Civilizations might have risen and fallen, stars born and died, and you would step back into a world that feels like the future. In that moment, you would not be traveling through time. You would have lived time differently. This is not science fiction. This is physics. This is the real, tested, repeatable nature of space-time, and it introduces a profound tension. If time is not fixed, then what is? If clocks can disagree, then what does it mean to be in the present? If now is different for you than it is for someone else, is now even real? Philosophers have long struggled with the nature of time, and physics hasn't resolved it. It's deepened the mystery. You think of the present as a blade slicing through the future and past, but in relativity, all moments exist. The past does not vanish. The future is not unborn. They are already there, waiting, existing, part of the space-time block. You move through this block along your personal line, your world line, and the shape of that line, curved by gravity, twisted by motion, determines how much time you experience. And that raises haunting questions. If every moment already exists, are you just tracing a predetermined path? Or are you somehow choosing which slice of the universe to experience next? And if someone can age slower than another, does that mean consciousness can stretch? That the self is tied to the geometry of the universe itself? Perhaps, perhaps not. But we know this. Time is not absolute. It is as malleable as clay, shaped by mass and energy and motion. It is elastic, not rigid. And that changes everything. It means your lifetime is not a fixed length. It depends on how and where you live it. It means that a second is not always a second. And it means that the universe, in its quiet elegance, does not treat all moments equally. Some flow faster, some slower. And all of them together weave the complex, multi-layered experience you call reality. So the next time you look up at a mountain, or down into a valley, or out at the stars, remember, time is flowing differently there. Not in theory, in truth. Your life is one strand in a larger weave of clocks, each ticking at its own pace, each singing its own rhythm. You are not just aging, you are dancing with gravity. And that dance, imperceptible as it may seem, is sculpting the very texture of your existence. And maybe, just maybe, when you close your eyes and feel a moment linger longer than it should, or vanish faster than it ought, you are brushing against the curves of time itself, curved not only by matter but by memory, not only by mass but by meaning. Because in a universe where time can bend, so can the story. And your story, like your time, is always more relative than you think. You can slow down time through intense focus or fear. Imagine a moment so sharp, so vivid, so electrically alive that it seems to break away from the flow of your life and hover in the air like a suspended breath. Like the pause before a crash, the instant your car veers off the road and gravity forgets how to behave, or the split second when you see a child step into traffic and your body moves before your thoughts catch up. In these moments, time doesn't just slow down, it fractures. The seconds stretch, widen, deepen, and in their new shape, you are suddenly capable of more awareness, more reaction, more memory. You can recall every detail, the glint of metal, the angle of your wrist, the texture of the air. These are the seconds that seem to last forever. But why? How does a clock in your head slow when every clock in the world keeps ticking on? The answer doesn't lie in the gears of time itself, but in the machinery of your mind. Because time, as you perceive it, is not a steady stream flowing outside you. It is a construction, a product, a subjective hallucination, crafted moment by moment by your brain. It's not what's happening. It's how you're processing what's happening. And when your brain enters a state of intense focus, trauma, fear, or flow, the architecture of that processing shifts. Under conditions of threat, when adrenaline floods your bloodstream, when cortisol ignites your ancient survival circuits, your brain doesn't just activate, it expands its processing bandwidth. It records more data per second. Your attention narrows, filters vanish, details sharpen. You become hyper-aware, not because the world has changed, but because your brain has turned up the gain on experience. And when you look back, that memory is thicker, more densely packed with sensory information, more emotionally charged, more complete. And because we judge the passage of time by how much we can remember happening, those dense memories feel longer. This is why terrifying moments seem slow. They're not slow while they're happening. You don't actually perceive them in slow motion, but they are remembered that way. You reconstruct the experience and interpret it as a stretch in time. And there's science to back this up. In one famous experiment, participants were dropped backwards from a 150-foot tower, falling in freefall for about 2.5 seconds. Before the drop, they were given devices to measure their perception of time, and afterward, they were asked to estimate how long they'd been falling. Universally, they overestimated the duration, some by more than double. But when researchers analyzed whether the brain was truly processing more frames per second during the fall, they found it wasn't. The illusion occurred in retrospect, not in the moment. The fear made the memory thicker, more textured, more expensive, and therefore, in memory, longer. This reveals something profound. Your perception of time is not a measurement. It's a feeling influenced by attention, emotion, cognition, and even narrative. Time slows not because the clock hesitates, but because you step more deeply into the present, because you absorb more per unit of clock time. It's not just fear that does this. The opposite, flow, does too. When you're immersed in a task you love, when your skill matches the challenge, when you're fully engaged, unself-conscious, and present, time seems to both vanish and dilate. Hours pass in minutes, or sometimes you feel like you've been working forever and it's only been 10 minutes. In flow, your brain is tuned, coherent, harmonic. Distractions fall away, internal dialogue dims, the self quiets, and your perception of time becomes plastic, malleable, elastic, sometimes fast, sometimes slow, depending on whether you glance at the clock or reflect on what you've accomplished. In this state, your brain's prefrontal cortex shifts its activity. The default mode network, often associated with self-referential thought and mind-wandering, decreases its noise. You enter a temporal vacuum, a moment that is only this, unburdened by the past or the future. And afterward, you remember it as a kind of sacred slowness, a zone in which you were more alive. Athletes describe it. Artists, coders, dancers, even surgeons. Time didn't change. They did. This reveals an astonishing truth, that subjective time is a tool, not a law. It can be bent by context, shaped by narrative, lengthened by emotion. Think of a boring meeting that feels endless, and yet is objectively shorter than the exhilarating trip you just took that seemed to disappear. Your memories are sparse in the meeting, rich in the adventure, and so the meeting feels longer in the moment but shorter in hindsight, while the trip feels shorter as it happens but longer in memory. This paradox, fast experiences feeling longer and slow ones shorter, is a clue. Your sense of time is a meaning engine. It is based not on duration, but on density, novelty, significance. That's why time seems to move faster as we age. The novelty fades. Days blur. Routines smooth over the raw edges of our perception. And so we lose time not because we have less of it, but because we see less of it. Children experience time as slower because everything is new. Their brains are forced to encode, attend, absorb. The world is unfamiliar, and so the memory archive grows faster. As adults, repetition makes days dissolve. The way to slow time, then, is to inject intensity, newness, fear, awe, immersion. These aren't philosophical tricks. They are neurobiological mechanisms. The amygdala, the brain's fear center, enhances memory consolidation when activated. The locus coeruleus floods the system with norepinephrine during stress, sharpening awareness. The thalamus changes its gating. The hippocampus bookmarks trauma. Together, these create experiences that, while unpleasant in real time, stretch forever in memory. But you don't need terror to bend time. You need attention. You need to look harder. Focus, not fear, is the cleanest tool to slow time. Meditators often report that time dilates in moments of deep awareness. Their breathing slows, not because the body is tired, but because the mind has stopped racing. In these states, time becomes fluid, not something to chase or escape, but something to feel. And this leads to a deeper question. If time is elastic, subjective, and built from awareness, what does that make you? Are you the clock or the reader of the clock? If you can stretch or compress time through your own state of mind, then aren't you partly the author of time itself? Not in the cosmic sense, not in terms of relativity or gravitational wells, but in the internal, experiential sense. Then maybe what we call a long life is less about years and more about moments fully lived. A single minute of deep presence can be worth more than a day of distraction. And maybe your life is not measured in how long you breathe, but in how much of your breathing you actually notice. Maybe time is not a river flowing past you, but a lens you keep adjusting, focusing, widening, tightening, distorting, clarifying. And through that lens, you sculpt your own existence. So the next time you feel life racing past, don't just curse the speed. Ask yourself, how present am I? How focused? How aware? How awake? Because in focus, you create depth. In fear, you carve density. In awe, you stretch the seconds like golden taffy, pulling more out of each heartbeat. You can't stop time, but you can change how it's written into your memory. You can slow it down, not with machines, but with meaning. And in a world that feels faster every day, maybe your most powerful technology isn't your calendar or your clock, but your attention, your quiet ability to look, to feel, to fully inhabit the now. Because the truth is, clocks measure rotation, physics measures motion, but you measure time in moments. And those moments, thick or thin, bright or blurred, rich or empty, are yours to shape. Even now, especially now, you never touch anything, your atoms just repel. Imagine reaching out your hand to touch the surface of a table, the wood cool beneath your fingertips, the texture coarse or polished, the sensation unmistakably real, and being told that this moment, this physical contact you've trusted all your life, is an illusion so complete, so convincing, that it masks a deeper truth. You never actually touched anything, not now, not ever. That table, no matter how solid it feels, has never met your skin in any fundamental way. The sensation you feel, the pressure, the texture, even the pain if you press hard enough, is not the result of atoms colliding, but of atoms refusing to meet, of invisible forces keeping every particle in your body at a microscopic distance from the world. At the scale of everyday life, this seems absurd. Of course you touched the table, you pressed a key, you held someone's hand, you kissed a forehead. But on the atomic level, the level where reality does not care what you believe, the story is different. There, nothing ever truly touches. Atoms are made of a dense nucleus surrounded by a cloud of electrons. And when two objects come close, it is the electromagnetic force, the repulsion between the negatively charged electrons of each atom, that prevents them from occupying the same space. Like two identical poles of a magnet, they push away, creating a barrier that feels like contact but is really resistance. You feel the illusion of solidity because the electromagnetic field pushes back against your attempt to penetrate it, and your nerves interpret that force as pressure. That's all. The atoms themselves, they've never met. The nuclei are still light years apart on their scale. You could zoom in endlessly and still find a chasm between the particles. You walk on the ground without falling through it, not because of structural contact, but because your atoms hover, held aloft by repulsion, like billions of tiny levitating fields interacting without touching. Even when you sit, even when you lie down, you are hovering, just by a distance too small for you to perceive. The same goes for every handshake, every hug, every kiss. No two bodies have ever truly made contact. And yet the illusion is so powerful that it defines your sense of reality. But once this veil is lifted, it opens a cascade of unsettling questions. If touch is not real, then what is real? If sensation is just the brain's interpretation of electromagnetic resistance, then where does the boundary lie between perception and deception? Is the world made of substance or of fields that simulate substance? Quantum mechanics tells us that matter is not the solid stuff we once imagined. Atoms are mostly empty space. If a hydrogen atom were the size of a football stadium, its nucleus would be a marble at the center, and the electron cloud would be a haze dancing in the upper stands. The rest? Nothing. And yet this nothing makes everything. Your bones, your brain, the chair you're not really sitting on. And here's where the mystery deepens. Because even though atoms repel one another and cannot touch, they can entangle. They can share information, become linked in such a way that the state of one instantaneously influences the state of another, no matter how far apart they are. So even while the universe keeps particles apart with invisible walls of electromagnetic force, it also stitches them together with invisible threads of quantum correlation, separation and connection, existing side by side. You never touch the world, yet you are inseparably woven into it. And consider this. If all physical contact is mediated by force fields, if what we call touch is really just interaction at a distance, then you are also defined by your edges, not by where your skin ends, but by where your electromagnetic field begins to resist intrusion. You are a region of space defined by the boundary at which you say, "Not here." Your body is less an object than a dynamic domain, an energy, structure negotiating with the rest of the universe. And if this is true for you, it's true for everything. Every object in the universe, every planet, every tree, every cell, is not so much made of matter as it is maintained by forces. The solidity of the world is an emergent property, not a fundamental one. It's a consensus between repelling fields, a negotiation masquerading as presence. This makes reality feel less like a solid and more like a performance. A highly coordinated ballet of fields pretending to be surfaces, masses, edges. Even friction, that seemingly tangible resistance, is not contact. It's a result of electromagnetic interactions between irregular atomic surfaces trying to slide past each other. Heat is the transfer of kinetic energy between particles that never touch. Electricity flows not through collisions but through the dance of electrons across potential barriers. The universe is built not of things, but of interactions, of patterns in motion, forces resisting, fields fluctuating. And all this leads to one staggering conclusion. The entire world you experience through touch is a simulation created by your nervous system, interpreting the pushback of electric fields as shape, texture, temperature, hardness. You don't touch objects, you interpret their denial of entry. Your fingertips are not reading matter, they are translating force. So when you run your hand along a wooden table or press your lips to a glass of water, what you're feeling isn't contact, it's rejection. And in that rejection, your brain builds intimacy. The deeper philosophical question becomes, if touch is an illusion, can we trust any of our senses? If none of them report reality directly, if vision is photons bouncing off surfaces, you never touch. If hearing is pressure waves vibrating air you never grasp, then your entire interface with the universe is indirect. You are a consciousness interpreting field effects. You live inside a story written by neurons, fed by signals that are never in direct communion with the world. But maybe that's not cause for despair. Maybe it's a kind of magic. Because despite the fact that you never touch anything, you can still feel everything. You can still build skyscrapers, paint masterpieces, cradle a child. You can still learn to play the violin, to sculpt marble, to send spacecraft to distant planets, without ever once making direct physical contact with the tools you use or the world you shape. And maybe, just maybe, that says something not about the limitations of matter, but about the power of mind. Because if the experience of touch is a neural construction, then intimacy is not about particles, it's about perception. And if we can generate the full emotional, physical, and psychological experience of touch through electromagnetic rejection, then what we call connection is not limited by physics, it's enabled by it. Even love, the most intangible force of all, is shaped by this paradox. You hold someone close, believing you are one. But the truth is, you remain forever apart, dancing at the edges of fields. And yet, somehow, the illusion becomes the truth. The non-contact becomes the connection. The repulsion becomes the bond. So the next time you reach out and feel the world beneath your hand, remember, you are not touching it. You are negotiating with it, feeling its refusal and interpreting that denial as presence. You are skimming the surface of forces so subtle, so ancient, that they have held the universe apart since the beginning. And in that separation, they have allowed everything to exist. Maybe reality isn't built from solidity, but from tension. Maybe existence itself depends on things not touching, on the infinite patience of particles that never collapse into each other. And maybe the greatest truth of all is this: we are most intimately connected, not when we merge, but when we hover. On the edge of merging, when we almost touch, forever suspended in the electric breath between being and becoming. There may be no objective now, just different observers, pasts and futures. Imagine standing at a train station as a locomotive rushes past, its engine a blur of metal and heat, its passengers staring through windows at something you cannot see. And in that moment, frozen between seconds, someone asks you, what time is it now for them? Not what time is it here, but what time is it there, on that train, inside that moving pocket of space and steel. You glance at your watch, feel the clockwork tick against your wrist, and answer instinctively. But what if your answer is wrong? Not because you made a mistake, but because the question itself has no meaning. What if now is not a universal moment that binds us all like a thread through pearls, but a personal illusion, a psychological crutch, a story your brain tells to hold together the chaos of time? Because in the deepest layers of physics, those mapped by Einstein's theory of relativity, there is no single objective now. There is no universal present that all observers share. What feels like a single, continuous moment to you may slice into someone else's past or stretch into someone else's future. In a universe where space and time are fused into a four-dimensional continuum called space-time, the notion of now collapses into perspective. The faster you move, or the deeper you fall into gravity's embrace, the more your now diverges from others. Two observers, moving at different speeds or standing in different gravitational wells, will disagree about the order of events. For one, a supernova might have already exploded. For the other, it hasn't happened yet, and neither is wrong. The universe simply doesn't provide a master clock. Instead, it allows each observer to carve their own timeline, their own reality, from the fabric of possibility. This isn't science fiction. It's been demonstrated experimentally, countless times. Muons, those ghostly particles raining down from cosmic rays, should decay before they reach the Earth's surface. But because they're moving so fast, time slows for them. From their perspective, they live longer. From ours, they reach us before dying. Both perspectives are valid, both clocks are right. Time, it turns out, is relative, not just in how fast it passes, but in how it defines what is real. In Newton's universe, time was absolute, universal, unchanging, a river that flowed identically for all. But in Einstein's cosmos, time is like a rubber sheet, stretching and bending depending on motion and mass. There's no central river. There are countless streams, each defined by an observer's velocity and gravity. And in this view, now is a slice through the space-time block, a cut through the loaf of existence. Different observers tilt their slices differently. What's now for you is not now for someone racing past at near light speed. Their slice tilts into what you call the past or the future. And yet, for them, it is still the present. So what is the present? Is it just a psychological artifact, the mind's way of organizing memory and expectation? Neuroscience seems to think so. Studies show that your brain lags behind real time. You don't perceive the world instantaneously. Instead, your brain collects sensory data in packets, every 80 milliseconds or so, smooths it, edits it, and presents it as a seamless flow. You don't live in the now, you live in the recently updated past. And still, We feel anchored in something solid. We feel we inhabit a point in time, a now, marching forward, leaving behind what was, approaching what will be. But physics suggests that past, present, and future all exist simultaneously. The space-time block doesn't flow. It is. Every moment that ever was or will be is etched into its structure. And our experience of motion through time is just our consciousness lighting up frame by frame like a scanner beam. The past isn't gone. The future isn't unborn. They are simply elsewhere in the block. From this view, death is not annihilation, it's location. A person who died still exists, not in our present slice, but in another, still intact, preserved, in the geometry of space-time. And if now is relative, then so is presence, so is memory, so is causality. Imagine two distant events, a birth on Earth and a death on Mars. Depending on how fast you're moving, you could see the death occur before the birth. In your frame, the funeral precedes the baby's cry. Does that mean causality breaks? No, it means simultaneity breaks. The idea that two things happen at the same time becomes observer-dependent. And this challenges not only physics, but philosophy. Because so much of human identity is built around the present. Be here now, we say. Live in the moment. But what if the moment is an illusion? What if your now is not shared by anyone else in the universe, not even the person sitting next to you? You and they are surfing different slices, navigating different timelines, slightly skewed by motion, by gravity, by position. And those differences grow with distance. Across galaxies, the concept of a shared now becomes meaningless. You cannot say, that galaxy is doing this right now, because now there is not your now. Your attempt to synchronize clocks with the cosmos is doomed. Light takes time to travel. Information is always delayed. What you see is not what is, but what was. Even the image you see of the moon is 1.3 seconds old. The sun, 8 minutes. Distant galaxies, billions of years. You are not observing reality. You are observing memory. The sky is a time machine. And here lies the most poetic truth. You live in a universe where the present is not a universal truth, but a personal story, a function of speed, gravity, biology, and perspective. There is no master timeline, no objective now. Only a shifting tapestry of overlapping experiences, each claiming its own spotlight. And this has consequences. If the present is subjective, then so is loss, so is love. Someone who is gone in your now may still be alive in another frame, their laughter still echoing through a slice of space-time you can no longer reach, but which still exists, frozen, eternal, untouched. And maybe that's enough to challenge the despair of mortality. Maybe it's enough to know that the people we lose are never truly erased. They are simply elsewhere in the structure, not gone, just inaccessible. And perhaps we too will linger, long after we are gone, encoded in the geometry of someone else's past. If now is not absolute, then presence itself becomes layered, textured, eternal. And if that's true, then maybe we should stop chasing time as if it's slipping through our fingers. Maybe we should stop treating the moment as something to be clutched, hoarded, worshipped. Maybe the real art of living is not in capturing the now, but in recognizing its multiplicity. Understanding that each person walks in a private corridor of time, brushing past others, sometimes touching, sometimes missing completely. And maybe the deepest form of connection is the realization that no two people will ever inhabit the same moment. They will only ever translate each other's light. So the next time someone asks, "What time is it?" Pause. Think. Understand that the answer depends not on your watch, but on your frame, your motion, your mass. Understand that their now and your now are not the same. And yet you meet, briefly, impossibly, in this miracle of misaligned realities, each carrying their own version of past, present, and future. And maybe, just maybe, that's what makes being alive so unspeakably rare. Not that we share a moment, but that we create one together, in spite of the universe's indifference to simultaneity. In a cosmos where now is a fiction, meaning is what we forge in the spaces between our clocks. And that meaning, unlike time, is something we choose. A particle's properties don't exist until you measure them. Imagine walking into a dark room and flipping a coin, but never looking at the result, just letting it spin somewhere in the shadows, unheard, unseen, unacknowledged. Now imagine that the coin never lands. It never becomes heads or tails. It simply exists in a cloud of maybes, a swirl of unresolved possibilities, not in one state or another, but in both, in neither, in all. This isn't a philosophical metaphor. This is quantum mechanics. This is how the universe behaves when no one is watching. In the realm of the very small, of electrons, photons, quarks, reality itself refuses to commit until you demand an answer. A particle's position, its momentum, its spin, even whether it exists as a wave or a particle, doesn't settle into certainty until it is measured. Until then, these properties are not merely unknown, they are undefined. They have no value. They exist only as a probability wave, a mathematical cloud of what might be, each potential stacked atop the other like overlapping melodies, waiting for the listener to choose which one to hear. This is the heart of the Copenhagen interpretation, the unsettling core of quantum theory. Before measurement, a particle occupies a superposition of all possible states, and measurement doesn't just observe, it collapses. It forces the wave function, the mathematical description of all possibilities, to snap into a single outcome. It doesn't reveal what was there, it creates what is. Reality is born in the act of observation, and this leads to a question so profound it borders on madness. Does the universe exist when no one is looking? Does the moon shine in the sky when no conscious being stares up at it? Einstein mocked the idea. He couldn't accept a universe so slippery. But experiment after experiment has confirmed it. Particles behave differently when measured. Electrons, fired through a double slit, form interference patterns, as though they're waves. But if you watch which slit they go through, they act like particles. The mere knowledge of their path collapses the wave. They choose. They decide. The act of observing changes the behavior. This is not a mechanical failure, not a limitation of instruments. It is a fundamental feature of quantum systems, and it shatters our classical worldview. In the Newtonian universe, objects have properties whether or not we measure them. A rock is solid whether you hold it or not. A tree falls with a sound even if no ear hears it. But in the quantum world, properties are not attributes. They are interactions. Position isn't a fact. It's a question you ask, and the answer depends on how you ask it. Electrons don't have locations. They have probabilities. The world isn't made of things, it's made of outcomes. And this brings us to the infamous observer effect, often misunderstood. It's not that human consciousness magically collapses wave functions. It's that interaction, any physical measurement, forces nature's hand. A photon bouncing off an atom, a detector recording a click, a camera capturing a path, all constitute measurement in the quantum sense. But the implication remains. Until such interaction, the particle is not in a hidden state. It is in no state. Not because it's hiding from you, but because reality hasn't committed yet. It's like asking what a novel means before it's been read. The meaning doesn't exist until interpretation. The story waits to be lived, and the particle waits to be known. Now ask, if properties don't exist until measured, what about you? Are you just a configuration of properties waiting to be observed? Is your identity, your thoughts, your feelings, your intentions already set? Or does it bloom into form only through experience, through self-reflection, through others' gaze? The quantum world suggests that definition is not inherent but emergent, that the act of attention births clarity, and in this way the smallest particles mirror the deepest truths of being. But this isn't just philosophy, it's been tested. In 2011, physicists conducted the delayed choice quantum eraser experiment. A particle goes through a double slit, but whether you later choose to erase or preserve the path information determines whether it behaved like a wave or a particle earlier. In other words, your future decision affects the particle's past. The act of measurement not only defines reality, it rewrites it. This throws causality into a tailspin. It suggests that time, too, is fluid in the quantum world. That cause and effect may not be fundamental, but derived from deeper, non-local truths. That events are not fixed, but braided across space and time, bound by correlation rather than chronology. The universe becomes a story without a fixed order, a choose-your-own adventure where the ending rewrites the beginning. And in this strange dance of potential and collapse, you are not a passive observer. You are an active participant. Every act of measurement, every choice to look, is a moment of creation, not of magic, but of manifestation. The world does not simply roll forward, ticking like a clock. It blossoms in flashes of interaction, like fireflies blinking into being when watched. And what does this say about reality itself? That it's not a stage with props waiting to be discovered, but a script that writes itself as the actors step into the light. That there is no objective truth waiting to be uncovered, only contextual outcomes shaped by the instruments of inquiry. A particle has no spin until measured. A system has no energy until probed. The universe has no single history, only a range of possible pasts consistent with the present. The wave function contains all these stories, and measurement chooses which one becomes real. So when you gaze into the world, you are not uncovering it, you are selecting it, you are collapsing the haze of maybes into one fleeting is, and then the wave function rebuilds, ready for the next question. The universe never stops offering possibilities, it only ever answers what you ask. And if that's not strange enough, consider this. Particles can be entangled, so deeply linked, that measuring one instantly affects the other, even across galaxies. Einstein called it spooky action at a distance, but quantum physics shows it's real. The act of measuring one particle defines the state of its twin, no matter how far they are separated. Again, the properties don't exist until measured, and yet, when one is measured, the other's properties snap into place. This suggests a deeper level of connection, of unity beneath separateness. That the universe, at its core, may not be a collection of things, but a network of relationships. And this insight reverberates beyond physics, because if existence itself is relational, if properties emerge only through interaction, then maybe the self is too. Maybe you don't exist in isolation, but in relation. Maybe your qualities, your character, your truth are not buried within you like fossils, waiting to be dug up, but built moment by moment in how you relate to others, to the world, to yourself. Just like a particle, you become what you are when you are engaged, when you are seen. So the next time you wonder whether the world is real, whether your choices matter, whether truth is fixed, remember, even a photon doesn't know what it is until it's asked, and neither do you. In this universe of shimmering potential, where even the smallest units of matter defy existence until observed, reality is not a given. It is an unfolding. It is a conversation between curiosity and cosmos, a whisper between uncertainty and attention. And the more you look, the more it becomes. You could fall into a black hole and appear frozen, forever to us. Imagine watching someone you love drift toward the edge of a cliff you cannot see, the border of reality itself, where light fails, time falters, and the known dissolves into the unknowable. They fall, not with violence, but with the slow inevitability of gravity, too strong to resist. And yet to your eyes, they never quite reach the bottom. They hover there, at the rim of existence, suspended like a final breath held just before the plunge, frozen in a loop of descent that never completes. This isn't metaphor, it's the physics of black holes. In the vast fabric of space-time, these entities are not just places where gravity reigns. They are boundaries of knowability, where time behaves not as a rhythm, but as a variable, warped beyond recognition. And when someone falls into one, from our perspective, From the external universe's frame of reference, they appear to freeze, not metaphorically, not as a trick of vision, but in real, measurable terms. As they approach the event horizon, the point of no return where not even light can escape, their image stretches, slows, and fades. Time, for them, continues. They may fall for seconds, but to us, watching from afar, they never quite vanish. The last photons escaping from their body take longer and longer to reach us, redshifting into oblivion until they become undetectable, but never truly gone. Their image lingers, their motion halts. They appear to us as if frozen in time, hovering eternally at the brink of the abyss. This phenomenon is a direct result of Einstein's general relativity, which tells us that gravity warps time. The stronger the gravitational field, the slower time flows. Near a black hole, gravity is so intense that time itself stretches infinitely. From the falling person's perspective, they cross the event horizon in finite time. They fall, they pass the point of no return, they descend into whatever lies beyond. But from our frame, an outside observer with no ability to follow, they never finish the fall. Their final moments play out more and more slowly until time appears to stop. This discrepancy is not a mistake or a glitch. It is built into the structure of space-time. It's the result of gravitational time dilation taken to its ultimate extreme. The clock near the event horizon slows to a crawl compared to a clock far away, and because information cannot travel faster than light, we cannot receive any further updates about their fate. They fall into silence, not just in sound, but in information. From our perspective, their story ends without ending, a permanent pause, a ghost on the edge of space. But inside, for them, time continues. They feel the seconds pass normally. They feel the pull increase, the heat rise, the tidal forces grow. They may survive the crossing, depending on the size of the black hole. In supermassive ones, like the millions of solar mass giants at the center of galaxies, the gravitational gradient near the event horizon is surprisingly gentle. A person falling in might not even notice the moment they cross over. They would drift across a threshold with no ceremony, no fanfare. And yet, to the outside world, that same moment never happens. The event horizon becomes not just a physical boundary, but a temporal fracture, a place where perspectives irreconcilably diverge. For the faller, the journey continues. For the watcher, it halts, forever. This paradox of perception invites deep philosophical questions. What does it mean for an event to occur if no one can ever witness its completion? If a person falls across a horizon and no signal ever confirms it, is the fall real? Is their survival real? Are they still alive in some meaningful sense? From one perspective, yes. From another, no. The universe no longer agrees on facts. Reality becomes observer-dependent. And this isn't just theory, it has experimental analogues. We've measured gravitational time dilation on Earth, between mountaintops and valleys, between orbiting satellites and ground stations. We know the principle is real, and as we extend it to the extremes of black holes, we find that reality itself fractures into frames of reference that cannot be reconciled. There is no universal perspective that can tell the whole story. Each observer sees a different slice of truth, and the black hole, that silent monolith, sits at the center of this divergence, both swallowing and preserving, erasing and immortalizing. Because even as the infalling person vanishes from our view, their gravitational imprint remains. The mass they carried adds to the black hole. The information they bore, quantum, structural, physical, is absorbed, or is it? This brings us to the infamous black hole information paradox. According to quantum mechanics, information cannot be destroyed, but according to classical general relativity, anything that falls into a black hole is lost forever. These two pillars of physics clash violently here. What happens to the identity of the person who falls in? Does it survive as a pattern encoded on the event horizon? Is it smeared across the boundary in a scrambled form, as some physicists believe? Or is it radiated back out, slowly, over eons, in the form of Hawking radiation, a ghostly evaporation process that may eventually destroy the black hole itself? If so, then perhaps the image of the falling person is never truly gone. Perhaps they are not only frozen in our eyes, but leaking back into the universe in subtle quantum echoes. Perhaps black holes are not graves, but prisons with the slowest possible leak. Or perhaps they are mirrors, reflecting not the person's form, but their quantum shadow, forever indistinct but never erased. And this leads to a haunting implication. From our perspective, everyone who has ever fallen into a black hole still exists, suspended at the threshold. Not as living beings, not as active minds, but as asymptotic ghosts, infinitely approaching disappearance, but never quite gone. They are trapped in a slow-motion goodbye that never concludes. And this imagery is more than poetic, it is physically accurate. The equations tell us this is what we'd see. The last photon, stretched and dimmed, hangs there eternally. And so the edge of a black hole becomes a cemetery of stillness, a gallery of unreachable moments, a canvas painted with the final frames of lives that went on beyond our view. And yet, to them, it was just a moment, just another step. They kept going. Their time never stopped. And maybe, inside the event horizon, they reached the singularity, a point where space and time curve so tightly that our physics fails. Maybe they were shredded by tidal forces, stretched into atoms and beyond. Or maybe, in that unknowable place, they were reborn. Some theories suggest the singularity is not the end, but a bridge to another universe, to another patch of space-time, to a rebirth beyond our reach. If so, then the frozen image we see is not a death, but a doorway, a farewell to a form we understood, and the beginning of something we cannot name. And maybe, just maybe, that's the point. That black holes remind us that our perspective is not privileged, that what we call now, real, gone, are all contextual, that the universe is a house of mirrors, each observer seeing a truth that no one else can confirm. And the more we chase objectivity, the more we find that truth is layered, sliced by gravity, warped by motion, and hidden behind horizons we can never cross. So the next time you stare into the night sky and imagine the black holes out there, those dark hearts of galaxies, those silent wells of eternity, remember that some of them are holding the final images of people, ships, signals that have fallen in, not vanished, not deleted, just frozen, suspended on the edge of time, looking back at a universe that can no longer reach them and never saw them leave. There's no absolute time. It ticks differently for everyone. Imagine standing in a crowded train station, hundreds of people brushing past you, each with a story, a destination, a secret rhythm of thought behind their eyes, and each with a different clock inside them, ticking at a pace uniquely their own, even if they all wear the same brand of wristwatch. Now imagine that those clocks, despite being synchronized by society, by satellites, by atomic timekeepers orbiting above, are not truly in sync at all. Not just metaphorically, but physically. That the very notion of a universal now is a comforting illusion, and that time, as real as it feels, is not a constant river, flowing equally for all, but a personal tide, affected by motion, gravity, and your unique place in the universe. In the deepest language of physics, there is no such thing as absolute time, no cosmic metronome ticking for all of us in harmony. What you call a second might not match mine. What you experience as simultaneous may be irreconcilably out of sync with someone moving past you. Time, it turns out, is not a backdrop. It is a dimension, woven together with space into something called space-time. A fabric that bends, stretches, twists, depending on where you are, how fast you're going, and how much mass is nearby. This was Einstein's revolutionary insight in his theory of relativity. Time is relative, not poetically, literally. If two people move differently through space, they move differently through time. If one travels faster, time slows down for them. If one lives deeper in a gravity well, closer to Earth's surface, for example, their time also runs more slowly than someone living on a mountaintop. The effects are tiny in daily life, but real, measurable, undeniable. This is not theoretical speculation. It is how the global positioning system works. The satellites orbiting Earth must adjust for both special relativity, because they're moving fast, and general relativity, because they're farther from Earth's gravity. Without these corrections, GPS would drift by kilometers each day. Your phone's map would become useless. The clocks on those satellites run slightly faster than ours, so they must be slowed down artificially to match Earthbound time. The truth hiding in your phone is this: time is personalized. The second you experience is not quite the same as mine, and the larger the distances, the more dramatic the divergences become. Astronauts aboard the International Space Station age more slowly than people on Earth, by fractions of a second, but it adds up. If you spent a lifetime in orbit, you'd come back younger than your twin. This is the twin paradox, a real prediction of special relativity that has been confirmed. Again and again, one twin travels at high speed, then returns. The one who stayed behind aged more. They didn't just feel time differently, they lived more of it. Their cells divided more. Their heart beat more times. Their mind had more thoughts. Their body accumulated more entropy. Because time, the flow of existence, is not equal across different paths through the universe. And this bends our understanding of what it means to be in sync with others. If two people don't share the same time, what does it mean to share? A life? A moment? A memory? The answer is complex and beautiful. It means every interaction is an alignment, a meeting of mismatched temporal rivers, brief and imperfect. It means no two people will ever see the same event in exactly the same way, not just perceptually, but physically. Their now is not your now. Your past is not their past. The very sequence of events can change depending on who's watching. In the Newtonian world, time was a strict ruler, identical for all. But Einstein shattered that ruler and replaced it with a tapestry, a grid that warps near stars and stretches with motion. And in this world, each person carries their own time like a private compass. This has staggering consequences. It means the universe does not contain a single objective timeline. There is no divine ledger recording events in a universal sequence. Instead, there are world lines, the paths of individuals through space-time. And each world line has its own clock, its own rhythm. Some of them are synchronized for a while. Others diverge. Some twist dramatically. Some loop. Some end. And what's more, even the order of events can become fuzzy at cosmic scales. In certain frames, event A happens before event B. In others, the reverse. And both are valid. There is no absolute sequence, just relativistic order. This is not just theory. It has been demonstrated in particle accelerators, where fast-moving particles decay more slowly. Time slows for them. Their clocks, internal, biological, quantum, stretch. This isn't optical illusion. It is temporal mutation, dictated by speed. But this doesn't only apply to extreme physics. It applies to us in quiet, philosophical ways. Think of how a painful memory can feel longer than it was, or how a joyful afternoon vanishes in an instant. How two people can sit through the same concert, and one feels time melt, while the other watches the clock. These subjective variations are underpinned by something deeper, our neurological construction of time, which itself is layered atop a relativistic framework. Even inside the brain, there's no master clock. Different regions process time differently. The cerebellum tracks milliseconds, the hippocampus codes sequences, the prefrontal cortex handles long-term narratives. Your brain is a democracy of ticking patterns, agreeing imperfectly on what just happened. So time, even in your own mind, is reconciled, not absolute. And now ask, what does this do to our sense of shared reality? If time ticks differently for everyone, then so does life. A prisoner in solitary confinement might feel 1 year as an eternity. A child immersed in play might feel an hour as a blink. A person with a terminal diagnosis might experience a week as a lifetime. And in each case, they are right, because time is not something you watch pass. It is something you inhabit. It is both physical and psychological, both clockwork and consciousness. And in this sense, there is no single time. There is your time, and mine, and theirs. And the challenge is not to unify them, but to understand them, to respect the different rhythms by which others live. Because we are not travelers on the same train, watching identical scenery. We are passengers on diverging paths through a universe, where time itself bends, stretches, and dances. And perhaps the greatest act of empathy is to recognize when someone else's clock runs faster or slower than yours. To understand that their world is not mistimed, it is differently timed, and that all we ever do is overlap briefly. So the next time you feel out of sync with someone, emotionally, intellectually, spiritually, remember that it may not just be miscommunication, it may be mismatch of time. And that's not a failure. It's part of being human in a relativistic world. It means that connection is a miracle, not a given. And the fact that we ever share anything, a thought, a conversation, a laugh, is something close to cosmic harmony. Because in a universe where clocks disagree and time bends to motion and mass, you and I are not in the same time. We are merely close enough to pretend. And maybe, in the grand scheme, that's all we need. Black holes may contain everything that ever fell into them. Imagine a door that opens in only one direction, a dark, silent threshold beyond which no message can be sent, no light can return, no story can be told. Now imagine that everything that crosses this invisible boundary doesn't vanish, but is instead kept, contained, remembered, not as whole, intact beings, but as information, scattered, encoded, pressed flat against a cosmic membrane like shadows, cast against eternity. This is not a myth. This is not poetry. This is physics. And that doorway, black, absolute, inescapable, is what we call a black hole. For decades, black holes were imagined as destroyers, devourers, points of no return, that swallow all and yield nothing. But now we are learning that black holes may not erase what they consume. They may instead store it. Every star, planet, ship, photon, or human that has fallen beyond the event horizon may still exist, not in the way it once was, not in shape or substance, but as information woven into the very fabric of the black hole's surface. It is as though the black hole keeps a ledger, an uneditable cosmic record of all that has crossed its threshold. This idea isn't just speculation, it's born from a profound tension between the two pillars of modern physics: quantum mechanics, which insists that information is never lost, and general relativity, which describes black holes as places where space-time curves into a singularity, and all internal structure collapses to an unknowable point. For a long time, these views clashed. If black holes destroy information, as general relativity suggests, then quantum mechanics breaks. If quantum mechanics is right, then our understanding of black holes is incomplete. This was the black hole information paradox, a question so severe it haunted the minds of Stephen Hawking, Leonard Susskind, Gerard 't Hooft, and countless others. And the resolution, still forming, still debated, seems to be this: black holes do not destroy information, they encode it. Everything that has ever fallen into a black hole is preserved, somehow, somewhere, somewhen, likely smeared across the surface of the event horizon in an ultra-thin pattern that records the quantum states of the fallen. This is the holographic principle, the idea that three-dimensional information about a volume of space can be stored on a two-dimensional boundary. Just like a hologram stores a full 3D image on a flat surface, a black hole may contain the full history of its interior on its outer skin. The information isn't inside the black hole, where physics fails and singularities lurk. It's on the black hole, etched into the horizon, like scars on a boundary we cannot cross. The larger the black hole, the more surface it has, and thus, the more information it can encode. This flips our intuition. We expect the capacity of an object to depend on its volume, but a black hole's information storage is proportional to its surface area. A sphere made of pure nothingness becomes the most efficient archive the universe has ever known. But what does it mean for information to be stored? Is it accessible? Can it be read? Can someone somewhere retrieve the identity of a person, a planet, a poem that crossed the horizon? Perhaps, if we ever understand the language of Hawking radiation. This is the subtle glow predicted by quantum field theory in curved space-time. Black holes evaporate, not quickly, not violently, but slowly, over unimaginable timescales. As they emit radiation, they lose mass, shrink, fade. But this radiation isn't pure randomness. It may, according to some theories, carry encoded information, like smoke, rising from a burning book that somehow allows you, in principle, to reconstruct the entire novel. If true, then black holes don't just contain the past. They release it, bit by bit, over eons. The act of evaporation becomes a kind of cosmic confession. Every emitted photon whispers something about what fell in. The final scream of a black hole may not be a roar, but a reconstruction, the universe remembering itself. This idea reshapes our view of death. If black holes don't erase, then nothing is truly lost. Everything that ever entered one still exists, not as a functioning being, but as a pattern, as information, as a potential reconstruction. Even you, if you were to fall in, would not vanish in totality. Your mass would add to the gravity. Your entropy would add to the chaos. Your story would add to the surface. And long after the stars go out and the last black hole begins to die, echoes of you might still be escaping, translated into the slow leak of radiation, the last song of a thing that never forgot. But let's step back, because this idea that black holes contain everything that ever fell in is more than a technical curiosity. It is a philosophical revolution. It tells us that the universe is conservative, not in temperament, but in principle. That reality values every interaction, every configuration, every moment, that even in the most extreme erasure imaginable, something is kept, that the structure of being resists deletion. This stands in stark contrast to our everyday intuition. We believe in loss, we witness decay, we mourn disappearance, but physics whispers otherwise. It says, nothing is ever truly gone. Only transformed, translated, stored, even if we don't yet know how to read the script. And this idea bleeds into consciousness, into memory. If the universe doesn't forget, perhaps neither do we. Perhaps memory is a kind of personal event, horizon, storing the essence of moments even when their form is gone. Perhaps our lives too are written on surfaces we cannot see. And perhaps the same laws that prevent a black hole from erasing its past apply, in some strange way, to the mind. But returning to the cosmos, if black holes contain all they've devoured, then the interior of a black hole is not emptiness, but compressed story. The horizon is not the end, but the edge of a great archive. The singularity is not a void, it's a cipher, and each black hole drifting through space is a library with no door. And now consider this. The center of our galaxy houses a supermassive black hole. Millions of stars have fallen into it. So have planets, dust, light, perhaps civilizations. And all of it, every atom, every particle, may still be there, etched on a sphere we can never touch. The black heart of the Milky Way is not silent. It is saturated, and if we could learn its language, we might read the entire history of our galaxy, not from telescopes, but from the skin of a shadow. So the next time you look up at the night sky and feel the hush of the stars, remember, some of them are gone, but not lost. Some light has faded, but not forgotten. Some matter has fallen, but not erased. Somewhere in the darkness between constellations, drift the most perfect containers ever built. Not by hands, but by gravity. Not by design, but by consequence. They do not shine, but they hold. And inside them, on them, is everything they have ever touched. All of matter could technically be just energy in a holding pattern. Imagine walking through a quiet room, running your fingers across a wooden table, tapping a glass of water, feeling the thud of your own footstep reverberate through the floor, and believing, as you always have, that the world around you is made of solid, tangible matter, atoms with mass, structure, boundaries. But now imagine peeling back the surface of reality, peering beneath what your senses perceive, and finding something astonishing. That all of it, the table, the glass, the floor, your hand, is not truly matter in the way you thought, but energy, cleverly trapped, stabilized, coiled into form. Matter, it turns out, may not be fundamental. It may be an illusion of stillness, a persistent whirl of kinetic patterns, energy held in a dance so stable that it appears solid. In the language of modern physics, everything you've ever seen or touched, your body, the mountains, the air, is made of particles. But these particles are not tiny marbles. They are vibrations in fields. The electron is not a dot, it's a ripple in the electron field. The quark is not a speck, it's a localized excitation. And what defines a particle is not its materiality, but its energy and behavior. When you see a chair, what you're really looking at is organized energy, interacting in a way that simulates solidity. This is possible because of one of the most profound truths ever uncovered, E-REMC2. Einstein's famous equation reveals that mass is a form of energy. The M in the equation doesn't refer to some magical substance. It refers to a quantity of energy in a resting state. That means all mass, everything with weight, everything you call stuff, is simply energy that isn't currently flying through space as light or radiation. It's energy at rest, held, contained, suspended, and that changes everything. It means that matter is not some primal clay from which the universe is sculpted. It is frozen motion, slowed and structured energy fields held in patterns by fundamental forces. Electromagnetic, strong nuclear, weak nuclear, gravitational. What we call solid is simply energy arranged into stability. Even the atoms that make you up, hydrogen, carbon, oxygen, are not solid things. They are mostly empty space. The electrons orbiting your nuclei aren't particles in paths. They are probability clouds, statistical smears of energy potential, never sitting still, never sharply located. The protons and neutrons in the nucleus are themselves made of quarks, bound together by gluons, particles that carry the strong nuclear force. And those gluons, massless, pure force carriers, energy in motion. The more you look, the less substance you find. You begin with a body, reduce it to cells, to molecules, to atoms, to subatomic particles, and finally to energy. What's left is not stuff, it's structure, pattern, relationship. A chair is not a thing, but a pattern of energy-stabilized relationships between fields. Your hand is not matter pushing against other matter. It is a dance of forces, of electric repulsion and quantum exclusion. When you push on a wall, your atoms are not colliding with the wall's atoms. They are exchanging force carrier particles, mostly virtual photons, mediating the electromagnetic resistance that gives rise to the illusion of touch. Beneath it all, it's energy playing roles. That's what matter is. Condensed energy, behaving with structure. But how does energy stabilize into matter? Why doesn't it just fly off as radiation? The answer lies in the quantum fields that permeate the universe. These fields are like invisible oceans that ripple when excited. Every fundamental particle corresponds to one of these fields. When energy excites a field in the right way, a particle is born. But some particles, like photons, are massless and travel at the speed of light. Others, like electrons, have mass. That mass arises because of the Higgs field, an omnipresent background that interacts with some particles and not others. As particles move through the Higgs field, they acquire inertia, resistance to acceleration, which we experience as mass. That mass is energy, so your mass is not a fixed trait. It's a measure of how you interact with the quantum world. If the Higgs field were gone, all particles would be massless. The universe would be light and radiation, no atoms, no structures, no life. The solidity of your body depends on this subtle interaction between motion and field, between energy and resistance. And what we call matter is merely energy caught in relationship, stabilized by fields, cooled by entropy, shaped by symmetry. And the more stable the pattern, the more we perceive it as real. But it's all temporary. Nothing stays still forever. Atoms decay, particles collide and annihilate. Mass becomes light. Stars fuse hydrogen into helium, releasing mass energy into radiation. When you eat food, your body breaks bonds and converts matter into usable energy. When you move, you're rearranging energy in space. When you die, your matter will not vanish. It will decay into radiation, into motion, into freedom. And so the arrow points in one direction. Matter becomes energy again and again. The reverse is also true. In high-energy environments, like the early universe or particle accelerators, pure energy can produce particles. Photons can smash together to create electron-positron pairs. It's reversible. But at every turn, the thing that's conserved is not mass, not identity, but energy. Energy is the fundamental currency of reality. Matter is just one form it chooses to wear. So perhaps we should stop thinking of matter as basic. Perhaps we should think of it as frozen fire, slowed down, light, structured tension. Perhaps every object is a momentary knot in the universal energy field, a bubble of organization destined to pop. And maybe you too are energy in a holding pattern, your thoughts, your memories, your body, your warmth, all the result of forces maintaining coherence in an otherwise chaotic system. If that's true, then identity is not a thing, but a process. You are a stable loop, an energy signature preserved by feedback, by memory, by biology. You are like a standing wave in a pond, not a thing, but a persisting pattern. And just as waves vanish when the source stops, you will one day dissolve, but the energy won't be gone. It will ripple elsewhere. It always does. And this brings us to a philosophical reckoning. If matter is just energy and form, then what is form? Why do some energy patterns persist while others vanish? Why does a chair last for decades while a flash of lightning vanishes in seconds? The answer lies in symmetry, in conservation laws, in entropy. Stable structures minimize energy loss. They survive because they are efficient. Matter exists where energy finds a home in balance, in structure. In this sense, reality is biased toward coherence. It prefers patterns that last. And perhaps consciousness itself, your awareness, your sense of self, is one of the most complex of those patterns. Energy not just in motion, but aware of its motion. And maybe that awareness is also temporary. A stable eddy in the river, a flicker in the current, but real and beautiful. And maybe that's enough. So the next time you pick up a stone or feel the ground beneath your feet, remember, you're not holding stuff. You're holding tension, pattern, delayed motion. You're feeling the resistance of energy pretending to be solid. And when you speak, when you move, when you breathe, you are not burning matter. You are releasing light trapped in form. You are a flare in the dark, dancing with every other structure born from this same invisible sea. Because in the end, all matter is energy caught in form, and all form is fleeting. If you orbit a clock, it will tick slower. Imagine watching a clock from across the room, its second hand sweeping forward in steady rhythm, indifferent to your gaze. And then imagine stepping onto a treadmill encircling that very clock, not walking casually, but accelerating until your feet barely touch the ground, until the room blurs and the clock becomes the central sun in a private orbit of effort and momentum. And as you circle it endlessly, you begin to notice something uncanny. The clock ticks slower, not from fatigue, not from your exhaustion, but from the fundamental physics of motion. You run, and the clock resists. Its seconds stretch, its ticks lag behind your memory of time. And this isn't a trick of your perception. It's a real, measurable, physical consequence of movement through space. Time itself dilates. In the framework of Einstein's special relativity, motion through space affects motion through time. When you move relative to something else, you experience time differently. Faster movement equals slower time, an inverse relationship written into the fabric of space-time itself. And when you orbit a clock, you're in motion relative to it. That motion distorts time. Your clock ticks slower than the one you're circling. But the truth is even deeper. Both clocks are ticking differently in each other's eyes. Time is not absolute. It is woven into motion, into frame of reference, into the very experience of being. And when you orbit a clock, whether on foot, in a spacecraft, or simply by spinning in gravitational embrace, you are altering time's flow, stretching seconds, shifting simultaneity, carving your own version of reality into the shared universe. This is not theory, it is fact. In particle accelerators, muons, unstable particles created from cosmic rays, last longer when moving at high speed. Their internal clocks slow. They decay more slowly than stationary ones. The faster they move, the more time bends. And in the human realm, astronauts aboard the International Space Station orbit Earth at 766 kilometers per second. Their clocks tick slightly slower than those on the ground due to their speed, but also slightly faster because of weaker gravity at that altitude. These effects counteract one another, but not perfectly. The balance is delicate. The result is measurable. The astronauts age differently. Their now is not our now. They return younger by fractions of a second. This is time dilation, both special, due to speed, and general, due to gravity. And it reveals a universe where time is not universal, not singular, not sacred, but local, personal, relative. When you orbit a clock, you create your own temporal frame, where your seconds elongate, and everything you observe outside moves faster. The world accelerates while you decelerate in time. And if you keep orbiting, if your speed increases, if you approach the speed of light, your time slows dramatically. A clock at the center of your orbit could tick through centuries while you age mere minutes. This leads to the so-called twin paradox. One twin stays on Earth, the other travels at relativistic speed around a clock, or a star, and returns younger. The universe has no single rhythm, no single beat. It pulses differently for each traveler. And yet, we believe we share time. We look at the same sunset, call it 7:30 p.m., and agree on our calendars, our clocks, our anniversaries. But underneath, that social synchronization is a sea of disagreement. Every heartbeat occurs in a different temporal frame. Every orbit alters the rate of time. Even your position, on a mountain, in a valley, on a moving train, tweaks your experience of time's flow. The higher you go, the faster time ticks. The deeper into gravity you fall, the slower time becomes. This is gravitational time dilation, another branch of relativity's legacy. A clock on a mountaintop runs faster than one at sea level. We've measured this using atomic clocks so precise that even a centimeter change in elevation registers as a change in time. Place two identical clocks, one on your desk, one on a shelf above, and after a while, they will disagree. Slightly, invisibly, but measurably. Time is sensitive, time is fragile, and motion, especially orbital motion, amplifies this fragility. In orbit, you're not just moving, you're moving around, and orbits generate unique relativistic effects. The clock you circle is still, and you are not. From your perspective, you're in motion. From the clock's perspective, it is you who has chosen a curving path. But from the cosmos perspective, both frames are valid. There is no privileged observer. All motion is relative, and that includes motion through time. Which brings us to a deeper question. What is time if its pace depends on your path? Is time something that flows, like a river? Or is it a coordinate, like a location? Is it absolute or emergent? The physics suggests the latter. Time is not a master. It is a byproduct. It emerges from the way space and energy interact. And when you move through space, especially in orbits, you bend your trajectory through time. A circle through space is a curve through space-time. Your velocity defines your aging. Your path defines your memory. Your clock ticks differently because it is taking a different route through reality. And so when you orbit a clock, you are not merely traveling. You are creating a temporal discrepancy, a divergence between two versions of now. This isn't fantasy. It's encoded in GPS satellites. The engineers must program corrections for time dilation caused by orbital speed and altitude. Without it, your navigation would be off by miles. Time is not just a theory. It is a calculation, a variable, a parameter that must be adjusted for motion. And orbit is a kind of motion with profound consequences. When you orbit a clock, you introduce temporal asymmetry. You stretch the interval between ticks, and if you keep orbiting long enough, you will fall out of sync, not subjectively, but absolutely. And this leads to a poetic realization. Time is not something you carry with you. It's something you experience in context. It depends on your surroundings, your speed, your choices. Two people in the same city, on the same street, at the same second, can have clocks ticking at different rates, imperceptibly, yes, but truly. And the difference grows with scale, with motion, with gravity. The universe is not a shared theatre with one ticking clock above the stage. It is a landscape of private rhythms, all overlapping, diverging, echoing. When you orbit a clock, you isolate yourself into a private rhythm. You become temporally displaced. You become your own story. Your seconds no longer match those of the clock. And yet the clock does not know. It ticks steadily, oblivious. But you know, you return changed. Your time has passed differently. And that difference, though small, is real. It accumulates. It means that time is not a line. It is a weave. It means that reality is not a monolith. It is a tapestry of temporal truths. Each thread, a clock, a motion, a path. And when those threads loop and orbit around each other, they create discord, not in noise, but in beat, in tempo. That is what orbit does. It shifts your tempo. It bends your beat. It rewrites your relationship with now. So the next time you look at a clock and see its hands move, remember, its pace is not universal. It is local. If you walk around it fast enough, long enough, you change the meaning of its second. If you fly around it, the distortion grows. If you orbit a massive object while the clock remains behind, the gap yawns open. And if you could orbit a black hole, dancing just outside the event horizon, time for you would nearly halt. The clock outside would spin through eons while you blink. One orbit, one breath, one instant for you, millions of years for the universe. This is not metaphor, this is physics. Orbit bends time. Speed bends time, and clocks, though they pretend to be neutral, are forever bound by motion, and so are you. The farther you look, the younger the universe becomes. Imagine standing beneath a sky so vast and ink black that it feels like the ceiling of reality itself, punctured by distant lights that flicker like ancient thoughts trying to reach you across. An immeasurable sea of time, only they aren't just far away. They're old, impossibly old. And the farther your eyes stretch into the darkness, the more you realize you're not just looking into space, but into the very memory of the cosmos. You are seeing not the universe as it is, but as it was. Because every photon that hits your eye tonight has been traveling for thousands, millions, or even billions of years to get there. And what that means, with a quiet strangeness that no amount of staring can ever normalize, is that the farther you look, the younger the universe becomes. You are, quite literally, gazing into a time machine, and each distant star, each galaxy smeared like a fingerprint of light across the void, is not just an object in space. It is a snapshot of youth, a preserved echo of a moment that no longer exists except in the light finally arriving now. This is no poetic flourish. This is physics. Light has a speed limit, about 299,792 kilometers per second. And though that is unimaginably fast by human standards, it is not instantaneous. When you look at the moon, you see it as it was 1.3 seconds ago. When you look at the sun, you see it as it was 8 minutes ago. When you peer at the Andromeda Galaxy, you are seeing it as it was 2.5 million years ago. You are looking into its past, into a version of it that might already be gone, or changed beyond recognition. And the farther your telescope reaches, the farther back in time it goes, until the night sky itself becomes a layered archive of cosmic history, stretching back to the very birth of the universe. What we call the observable universe is defined not by distance in kilometers, but by distance in time. The most distant light we can detect, the cosmic microwave background, has been traveling for about 13.8 billion years, almost since the beginning of everything. That light comes from a time when the universe was just 380,000 years old, and matter had finally cooled enough for atoms to form and photons to travel freely. That light has been stretched and softened by the expansion of the universe, cooled to just a few degrees above absolute zero, but it still carries the imprint of that infant cosmos, a whisper from the edge of time. The irony is that the farther we look, the more primitive everything seems. Galaxies appear less structured, stars less mature, chemistry less complex. We are looking into a younger, simpler, more chaotic universe, one that hadn't yet sculpted the intricate forms we now take for granted. The large spiral galaxies we see today were once clumpy blobs of stars colliding into each other. The rich clouds of elements that now form planets and people were once the hot ashes of the first generations of stars. The early universe was a wild place, unfiltered, energetic, and raw, and when we look far enough, we see it all unfolding like a slow-motion explosion frozen in reverse. But that backward view has a boundary, because while we can see the light, from long ago we can never see the present of those same galaxies. As the universe expands, space itself stretches, and distant galaxies are being carried away from us faster than light, not because they're moving through space quickly, but because space itself is expanding between us. Some galaxies that emitted light billions of years ago are now so far away that their new light will never reach us. What we see is a fossil, beautiful, illuminating, but unchanging. It's a form of cosmic heartbreak, to see something so clearly, yet know that you can never see how the story ends. In the farthest reaches of the universe, we are forever trapped in its childhood. And this is not just a curiosity of astronomy, it is a limitation of reality. The universe has an information horizon, a boundary beyond which light has not had time to reach us, and perhaps never will. We are surrounded by mystery, not just because we are small, but because time itself constrains our access to the now. What we call the present universe is actually a mosaic of past events, stitched together by the time it takes for their light to travel. And so, your map of the cosmos is not a map of now, it is a map of then. Every direction you look is a bi-direction into the past. And this gives rise to a philosophical inversion. We live in the present, but we see only the past. We act now, but we observe then. Our understanding of reality is always slightly outdated, and in cosmic terms, embarrassingly so. But perhaps even more unsettling is what this means about time itself. There is no single, objective now in the universe. Because of the finite speed of light, the concept of simultaneity breaks down across large distances. Two events that seem to happen at the same time from one perspective may appear to occur in different sequences from another. This is not an illusion. It is a consequence of Einstein's relativity. Time is not absolute. It is flexible, observer-dependent, and woven into the fabric of space itself. And when we look far away, we are not just looking into space. We are interacting with the very structure of time. In this way, astronomy becomes not just a science of stars and galaxies, but of memory, of chronology, of existence as an unfolding narrative that can only be read backward. And like any good story, the further back you go, the more vital the early chapters become. They reveal how the present came to be and how fragile its emergence really was. Without those early stars, there would be no carbon, no oxygen, no iron. Without those early collisions, no spiral arms, no habitable planets. Without those ancient photons, no picture of the cosmos. And without the time delay built into every photon's journey, we would not know our origins at all. So the delay is not a curse, it is a gift. It is the universe's way of allowing us to see our own prologue, of showing us not only what is, but what was, and what might never be again. Because this era we live in, this brief blink where the night sky is filled with galaxies and background radiation and knowable history, will not last. The expansion of the universe is accelerating, driven by a force we call dark energy. And, as time goes on, more and more galaxies will slip beyond our horizon. Eventually, only the local group, the Milky Way and its nearest neighbors, will remain visible. The rest of the universe will fade into darkness, not because it's gone, but because it has become unreachable. Future civilizations will look up at a black sky and see no trace of the Big Bang. No background radiation, no expanding cosmos, no clues to their own origins. They will be marooned in time, blind to the past that once flooded every telescope with light. But we, here, now, are still connected to that past. The light is still reaching us. The record is still playing. And so, when you gaze at the sky tonight, know that you are not simply stargazing, you are time traveling. You are looking into a younger universe, a wilder cosmos, a baby picture of everything you call real. And perhaps, in some quiet corner of your mind, that realization will echo in ways you don't expect. Because if the cosmos reveals its secrets only after long delay, maybe your own truths do too. Maybe your understanding of yourself, of love, of meaning, of fear, is also shaped by the slow unfolding of time. And maybe, just maybe, the deeper you look into your own darkness, the younger something inside you becomes. Not because you are regressing, but because you are remembering. You are seeing the early light of your own being. You are finding the beginning, not by turning around, but by looking farther and deeper into the night. Your mass increases when you speed up, even if you can't feel it. Imagine sprinting through a silent, endless tunnel, where the faster you move, the heavier your steps feel, not because the tunnel is changing, but because you are. As your speed rises, something imperceptible within you begins to shift, as if the very concept of your being is resisting the velocity you're trying to achieve. You don't feel it in your breath, your bones, or your heartbeat, yet physics assures you that the change is real, that your mass, the fundamental measure of your resistance to acceleration, is growing. Not metaphorically, but literally. The faster you go, the more you weigh, not in the sense that your bathroom scale would notice, but in a far deeper, more cosmic way. And here lies one of the strangest truths of relativity. Motion isn't free. It comes at a cost, and that cost is mass. As you accelerate toward the speed of light, your mass increases, asymptotically, endlessly, becoming heavier and heavier until no force in the universe could push you a fraction faster. And this isn't science fiction. It's the foundational bedrock of Einstein's special relativity, a theory that forever fractured our naive ideas of motion, inertia, and the limits of physical experience. According to Newton, mass is mass. It doesn't change with speed. It doesn't care how fast you go. But Einstein looked deeper. He saw that time, space, and mass are not constants, but interwoven aspects of a single dynamic reality. And from this insight emerged a staggering implication. As an object approaches the speed of light, its energy doesn't just make it go faster, it makes it more massive. This isn't a rounding error or a mathematical quirk. It's a fundamental truth baked into the fabric of the universe. Every time you push something to go faster, you're not just altering its velocity, you're changing what it is. You are giving it energy, and because of the famous equation E error mc2, energy and mass are one and the same, merely expressed in different currencies. What this means is that motion isn't just a change in position, it's a transformation of being. Your identity, at the atomic level, is stretching, bending, resisting. And yet, as a human being, you feel none of this. You walk, run, drive, fly, and even orbit the Earth. But your body never whispers the truth of your growing mass to your senses, because the speeds we encounter in daily life are but a flicker in the eye of light. At 100 kilometers per hour, your increase in mass is so tiny, so minuscule, that it would take machines of absurd sensitivity to even register it. But scale that up, reach toward a fraction of the speed of light, and the effect blooms into reality. Particle accelerators, like the Large Hadron Collider, prove it daily. Inside these titanic machines, tiny particles are spun faster and faster, nearing the speed of light. And as they accelerate, they get heavier. Not theoretically, measurably. Their mass increases so dramatically that engineers must input more and more energy to keep them gaining speed. Yet the particles approach a limit they cannot cross. No matter how much energy you pour in, they never reach light speed because their mass grows faster than your ability to push them. And that's the ultimate cosmic catch. At light speed, mass becomes infinite, and to accelerate anything to infinite mass would require infinite energy, a price no universe can afford. This truth builds a wall, not of brick or stone, but of law. A speed limit not enforced by police, but by physics itself. But there's something deeper here. Something that echoes beyond formulas and calculations. It whispers to us about the relationship between effort and identity. About how pushing yourself to extremes changes not just your path, but your substance. And it humbles us, because even the smallest particle carries a weight that can grow beyond comprehension. Imagine a spaceship, sleek and silent, accelerating through the void. To those on board, everything feels normal. The engines hum, the walls don't press against them, the coffee still swirls in its mug. But outside, to an observer watching from afar, something remarkable is happening. The ship is gaining not just speed, but inertia. Its resistance to further acceleration is climbing. It is, in a very real sense, getting heavier. Its mass is increasing with every jolt forward, every flicker of energy turned into motion. And if it ever dared to race too close to the speed of light, it would require more power than 1,000 suns just to inch a little faster. This is why light itself, the fastest thing in the universe, has no rest mass. Because only massless things can travel at light speed. Everything else is anchored, chained, held back by the very fabric of what it is. And yet we try. We build faster jets, swifter probes, more powerful engines. Because we are creatures obsessed with speed. Not just physical speed, but speed in thought, speed in progress, speed in life. But what if every time we try to go faster, we're unknowingly becoming heavier, slower in another way, bound by a kind of spiritual inertia? What if speed always costs us something we don't feel until we've already paid? The science says yes, in the literal sense, but the metaphor is equally haunting. Perhaps the very effort to escape who we are, to become something more, something better, something faster, adds weight to our existence. Perhaps growth is a kind of gravity, a slow, invisible tug on our essence that deepens the further we travel from our origin. And perhaps this is why every meaningful journey, scientific, emotional, or existential, requires not just motion, but endurance. Because the faster you go, the harder it becomes to continue. And the universe doesn't let you skip that tax. It enforces it through laws that no willpower can override. And still, there's beauty in that resistance. Because that growing mass, that ever-thickening essence, is also energy. What holds you back is also what gives you power. The mass you gain is not a burden, but a badge, a signal of the incredible energy it took to move you that far. Every step forward in velocity reflects a step deeper into the mystery of being. And it tells us something fundamental about the nature of effort, that transformation isn't free. That becoming something more, whether a faster particle or a wiser person, always demands a price. You may not feel your mass increase as you speed up, but it happens. Just as you may not feel the emotional weight of your growth until long after it has settled into your bones. And if the universe teaches us anything through this law, it's that limits are not failures. They are boundaries that define the shape of change. They are reminders that even in the emptiness of space, there is friction. not through air or wind, but through the laws of reality that bend, stretch, and hold everything accountable. So the next time you move forward, whether in a car, in thought, or in life, remember, there is more happening than motion. There is a quiet, invisible transformation underway. Your mass is shifting, your inertia rising, your very identity reshaping itself in response to the energy you choose to spend. And even if you can't feel it, the universe does. It remembers, it resists, and it reveals the strange truth that to go faster is to become more, not less. The force that holds your body together is mostly empty space. Imagine trying to grasp smoke with your bare hands, fingers closing around something that looks solid from a distance, yet vanishes the moment you try to touch it. Now imagine learning that your very body, the thing you sleep in, walk in, cry in, and call me, is no different. That it too is built from what appears to be substance, but is in truth a delicate illusion held together by invisible forces in oceans of emptiness. Every breath you take, every heartbeat, every step, every glance in the mirror is powered by a biological architecture that feels dense, tangible, and whole. Yet it's made almost entirely of nothing. You are not solid in the way you think you are. In fact, if you could somehow strip away the forces holding your atoms apart and collapse all the matter in your body into a truly solid state, eliminating the space between the subatomic particles that make you you, you would fit into a cube smaller than a grain of sand. Your body, your organs, your memories, your soul, all reduced to something so tiny it would barely cast a shadow. The rest, over 99.9999%, is empty space. But this emptiness isn't accidental, and it's not a flaw. It is the very architecture of matter itself. To understand this is to step into a realm where solidity is an emergent illusion and force is more real than form. Every atom in your body is composed of a nucleus, a dense, minuscule cluster of protons and neutrons, surrounded by a vast cloud of electrons, which don't orbit in neat circles like planets, but instead exist in probabilistic clouds, described by the eerie mathematics of quantum mechanics. The size of the nucleus is vanishingly small compared to the atom as a whole. If an atom were the size of a football stadium, its nucleus would be a single grain of rice sitting at the center, with the electrons buzzing somewhere near the outer walls, and the rest, all of it, would be void, empty. And yet this structure is not fragile. It's held in place by one of the most powerful and fundamental forces in the universe, electromagnetism. When you touch a table, a wall, or another person's skin, you believe you're making contact, but you aren't. What's really happening is that the negatively charged electrons in the atoms of your fingers are repelling the electrons in the atoms of what you're touching. You feel pressure, you feel resistance, but no particles actually collide. What you're feeling is the electromagnetic force doing its job, keeping your matter from merging with the matter around you. Without it, you would pass through walls, fall through floors, and dissolve into the air like breath on glass. This force, invisible and constant, is what holds you together, what maintains the integrity of your skin, your bones, your brain. It is the reason you have boundaries, the reason you don't collapse into a puddle of atomic debris. And it's not just your skin that benefits. Inside each atom, other forces are at play. The strong nuclear force, which binds quarks into protons and neutrons, and binds those into the nucleus. The weak nuclear force, which governs radioactive, decay, and the processes that power the sun. All of these forces work together to give rise to the illusion of solidity, to the experience of self, but they do so not by filling space, but by defining it. The very fact that matter takes up space is because of these interactions. Without them, even our best microscopes would find nothing there at all. This realization leads to a strange kind of awe, because it tells you that the body you inhabit is not a sealed container of material, but a symphony of structured energy. Your muscles are not blocks of stuff. They're regions where forces balance against one another. Your heartbeat isn't just a mechanical thump. It's the echo of ionic waves triggering electromagnetic reactions in muscle cells. Even the firmness of your bones is not because calcium atoms stack like bricks, but because their electron fields repel with such rigidity that we interpret it as solidity. Everything you are, your shape, your touch, your resistance to the world, is not made from matter alone, but from the way matter organizes itself around emptiness. And the deeper you look, the stranger it becomes. Because even protons and neutrons, those dense particles in the nucleus, are not fundamental. They're made of quarks, held together by gluons, particles that don't just connect like strings, but behave more like fields dancing across an infinite void. If you remove the energy of those fields, the proton would vanish. Its mass, like your mass, doesn't come from solid chunks, but from the swirling storm of movement and force within. Mass itself, the thing we use to measure substance, emerges from the energy of interaction. It is being as defined by doing. You are, quite literally, the shape of force fields frozen in momentary balance. And so the idea of your body being you becomes more fluid. Because if you are not made of matter in the way you thought, if you are mostly space, organized by invisible forces, then what is the boundary between you and the world? Is it where your skin ends? Or is it where your field of influence fades? And what of touch, love, pain, experiences rooted in the body? They are too responses to forces, interpretations of fields. When someone touches your hand, their electrons don't enter your atoms, but their presence shifts your fields, stirs your nerves, activates your brain. A kiss is not two lips colliding. It is the convergence of boundaries that never truly meet, but influence each other profoundly. And if all this is true, if you are a being built of mostly nothing, then perhaps what makes you you is not the stuff you're made of, but the way that stuff moves, resists, and connects. Maybe your identity is not in your particles, but in your pattern. In the dance, your atoms perform within the empty halls of your existence. This reframes everything: your sense of strength, your fear of disintegration, your belief in what is real. Because solidity is not truth, it is sensation. And behind every sensation lies structure, and behind structure lies emptiness. And behind emptiness lies what? Potential? Law? Mystery? You are not a statue chiseled from stone. You are a web of activity, humming with energy, balanced on the knife edge between being and dissolving. Every step you take is a defiance of entropy, a gesture that says, I will hold together one more moment, I will persist through one more breath. And all of it is built from nothing, from forces acting across voids, from tensions that do not collide but maintain respectful distances. You are not a solid object. You are a relationship of energy and space. And if that doesn't make you sacred, what does? Galaxies rotate too fast, suggesting there's invisible mass. Imagine standing at the edge of a colossal spinning disk, hundreds of billions of stars swirling around a glowing center like diamonds flung into orbit, and watching it all defy the rules you thought governed reality. You expect, like with any spinning object, that the outermost pieces would lag behind, pulled outward by centrifugal force and bound weakly by gravity. But instead, you see something that should not be. The stars at the outer edges, light years, from the galactic core, are moving as fast as, or faster than, those close to the center. It's as if the hands of a giant cosmic clock have slipped loose from Newton's grip and begun spinning in a rhythm that violates the very laws we once believed were unshakable. This is not a metaphor, it's observation. When astronomers measure the rotational speed of galaxies, especially the spiral kind like our Milky Way, what they find is a mystery so persistent and profound that it forced the rewriting of our cosmic narrative. Stars orbiting far from the center should, by all classical expectations, be moving slower than those nearer the galactic heart, just like the outer planets of our solar system orbit more slowly than the inner ones. Yet what we observe is a flat rotation curve. Instead of dropping off, the speed of stars remains constant, sometimes even increasing with distance. And this isn't a rare anomaly. This is the rule, the norm, the universal whisper that something enormous and unseen, must be hiding in the dark. Enter dark matter, a phrase so simple, so poetic, yet packed with implications that shatter the boundaries of our understanding. This invisible mass, dark, not because it is black, but because it does not interact with light, must be there to keep galaxies from flying apart. It must outweigh the visible matter by a factor of 5 or more, surrounding galaxies in vast, ghostly halos that anchor their spinning limbs. But here's where it gets even stranger. We have never seen dark matter. We have never touched it. It does not emit, absorb, or reflect light. It does not glow, cast a shadow, or leave a trace on photographic plates. We know of it only by inference, by watching how it bends the path of light from distant quasars, how it sculpts the cosmic web, how it tugs on stars that would otherwise drift into deep space. We call it matter, but it could be something else entirely. A field, a particle, a failure in our understanding of gravity. But whatever it is, it's massive. It shapes the universe. It holds galaxies together like invisible glue. And it is everywhere, perhaps even within us. The metaphor is almost irresistible. A universe where the unseen outweighs the seen, where the visible world is just a thin film stretched across a deeper, hidden structure. It's more than a scientific anomaly. It's a philosophical revelation. What if most of what is real can't be seen? What if the forces that shape us, cosmically and personally, are silent, undetectable, yet absolutely essential? Dark matter is not just a scientific placeholder for what we don't yet understand. It is a mirror. It shows us that our vision is incomplete, that the universe, like the human heart, contains mysteries that defy transparency. And so we look for it, in laboratories buried beneath mountains, in detectors chilled to near absolute zero, in the subtle wobble of stars and the whispers of ancient radiation. We hunt it with telescopes and with theory, with simulations that span cosmic epochs and equations scribbled in chalk. We try to trap particles that may not even exist, imagining WIMPs and axions, sterile neutrinos and supersymmetric shadows, and still, it eludes us, like a ghost that rearranges furniture when you're not looking. And yet we cannot let go, because the evidence is relentless. Galaxies rotate too fast. Clusters of galaxies are more tightly bound than their visible mass allows. Gravitational lenses bend light more than they should. The early universe evolved too smoothly, too evenly, unless something invisible helped sculpt its growth. Even the cosmic microwave background, the baby picture of the universe, hints at an unseen scaffolding. It's as if the universe is whispering in code, "I am more than you can see." And so we are forced to reconsider what it means to know. We once believed that seeing was believing, that truth revealed itself in the light. But now we know that light is not the final arbiter of reality. That absence of evidence is not evidence of absence. That the most profound influences might leave no visible trace. And this changes us. It changes how we look at the stars and how we look at each other. Because if galaxies can be shaped by what they cannot see, then so can we. If the cosmos dances to the rhythm of an invisible drummer, then perhaps our thoughts, our fears, our loves, too subtle to be measured, are more real than we imagined. And yet, science does not yield to poetry. It demands answers. It demands mass and spin and cross-sections. So we continue our search. We build better detectors. We refine our models. We consider the possibility that dark matter is not a particle, but a misreading of gravity itself. That maybe Newton and Einstein were both right but incomplete. That gravity, at the scale of galaxies, behaves in ways we do not yet understand. This gives rise to alternative theories: MOND, TVIS, emergent gravity. These challenge the dominance of dark matter by reimagining the rules, but none have yet explained all the data. The standard model remains: there is more matter than we can see. And this is not just a quirk of astrophysics. It's a foundational truth about our place in the cosmos. It means that our sun, our planet, our very bodies, float within a sea of unseen mass that is as real as the stars. It means that the night sky is not just a canvas of light, but a map of gravitational relationships with invisible players. And it means that to understand the universe, we must embrace what we cannot touch. This is humbling. It reminds us that human senses are limited, that human instruments, no matter how advanced, are shaped by the same evolutionary lens, that our theories are provisional, that the universe is not obligated to make itself visible to our biology. And yet, we persist. Because the galaxies persist. They spin with impossible grace, their arms extended like dancers frozen in time, held not by their own mass, but by something beyond. Something that does not flicker or fade, something that endures. And so we watch them, these great spirals of fire and dust, knowing that their defiance is a message, that their impossible rotation is a code waiting to be cracked, that within their speed lies a secret older than light. And we lean closer, not with eyes, but with wonder. Because even if we never see the hidden mass, even if it remains forever cloaked, we have already learned its most important lesson, that reality is more than appearance, that what binds the universe is not always visible, and that sometimes, to find truth, you must trust what you cannot see. In a flat universe, you could travel forever and return to the same spot. Imagine setting out across an endless plain. No mountains, no valleys, no curves in the earth. Just a perfectly level expanse stretching out in every direction. Flat as thought, eternal as time, where every step feels the same and the horizon never changes. You walk for hours, days, years across this smooth canvas, until one day, without warning, you find yourself right back where you began. No change in direction, no reversal, just a seamless loop, as if space itself folded quietly behind your back while you moved forward. It seems like magic, but it's not. It's geometry, it's physics. It's the unsettling beauty of a universe that might be flat, not in the sense of two dimensions, but in the way that space and time are woven together across a cosmic scale so vast that straight lines can bend and infinite journeys can become circles. This is not mere speculation, it's a reflection of one of the most profound questions we can ask about existence. What is the shape of the universe, really? Not the stars or the galaxies, but the space between them. Not the objects, but the void they inhabit. Is it curved inward like a sphere, curved outward like a saddle, or perfectly flat like a sheet of paper that stretches without edge? For decades, scientists have sought an answer through the flickering light of the early universe, reading the faint patterns in the cosmic microwave background, the radiation left over from the Big Bang. These patterns are not random. They are the universe's fingerprint, and they tell a story about the geometry of space itself. What they reveal with stunning consistency is a universe that is flat, not curved like a globe, not warped like a trumpet, but flat, smooth, balanced. This may sound simple, but the implications are staggering. In a flat universe, parallel lines never meet. Light travels in straight paths across billions of light years. Angles of triangles always add up to 180 degrees. And most hauntingly, if space is also finite but unbounded, then like walking around the surface of a sphere, you could travel in a straight line forever and eventually return to where you started, without ever encountering an edge. You would never fall off the universe because there is no edge to fall from. You would just keep moving through the same seamless stretch of existence until the past catches up with you in the future. This idea breaks something open in the human mind. Because we're used to boundaries. We're used to beginnings and endings, to boxes and borders. We imagine the universe like a container, something you could leave or exit or climb above. But the truth, as described by general relativity, and observed in the structure of the cosmos, is that space might curve back on itself in such a subtle and infinite way that the idea of outside becomes meaningless. You are always inside the universe. Even when you think you've reached the edge, you're still within the loop. This brings us face to face with a paradox, a flat universe that loops back on itself, because we tend to think of flatness as infinite and open, but space can be both flat and finite if it is topologically twisted in just the right way. Like the surface of a torus, a donut shape, where you can keep walking in a straight line and end up where you began, not because you turned, but because space curved under your feet while keeping the rules of flat geometry intact. This possibility means that the cosmos may be a vast hall of mirrors, repeating patterns at unimaginable scales, where light from distant galaxies could circle the universe and return from the other side, appearing as new galaxies, when they are in fact the same ones seen from a different path. It means that in the deep future, an explorer could launch a ship and set course on a straight trajectory, and if they waited long enough, maybe trillions of years, they might watch their own tail lights vanish into the past and appear ahead of them, circling back through the silent folds of space. But this is not just a game of geometry. It forces us to confront the nature of boundaries, of existence, of identity. If there is no edge to the universe, then where are we? Not in the center, because in a flat and unbounded cosmos, every point is as central as any other. Not near the end, because there is no end. We exist in the midst of a fabric that folds and stretches and reflects, but never tears or terminates. And this affects how we see ourselves. If the universe has no edge, then neither do our questions. We must stop thinking in terms of beginnings and ends and start thinking in terms of cycles, recursions, echoes. Even time in such a universe could be part of the loop. A universe that is flat and finite might allow for a temporal loop, where events are not just connected, but recycled. Perhaps your birth was not the first. Perhaps the moment you call now has already happened, countless iterations ago, in a cosmos that loops not just through space, but through story. This is not science fiction. It's a legitimate implication of what cosmologists call the closed flat universe, a space that is locally flat, but globally twisted. Such a topology would preserve the laws of physics, allow for infinite travel, but bind the traveler in a kind of cosmic Ouroboros, a snake eating its own tail. But here is where the human heart resists. Because we long for resolution. We want to know where the map ends, where the road drops off, where the stars finally stop. A looping flat universe denies us that closure. It says, gently but firmly, that we may never find the edge, because it does not exist. It tells us that we are not on a journey toward the outside, but within a journey that circles inward forever. And that makes our questions deeper, not smaller. Because if the universe has no edge, then where did it begin? And if it loops forever, then what does that mean for causality, for time, for free will? Do our choices matter in a cosmos that might replay itself endlessly, always returning to the same spot, the same stars, the same you? These questions cannot be answered with equations alone. They require imagination, humility, awe. They ask us to feel our way into a space that cannot be pictured but only intuited, to accept that the universe may be stranger than we can think and more elegant than we can fear. Because a flat universe that curves back on itself is not a prison, it's a wonder. It means you can go anywhere and still belong. It means that exploration and return are the same path. It means that your place in the cosmos is not marked by a border, but by movement. And movement never ends. So the next time you look up at the stars, know that what you see is part of a great, silent ring, a tapestry that may fold around itself in ways you cannot yet detect. And in that silence, in that shape without edge, lies the most beautiful idea of all, that the journey and the destination are not separate. They are one, and you are always in both. Hotter gas can cool faster than colder gas. Imagine standing beside a fire so hot, so wild with energy, that its very presence warps the air and wavers the edges of your vision. A flame not built for warmth, but for release, for letting go, for surrendering heat into the void. Now imagine a second fire, smaller, gentler, simmering like a memory instead of a storm. Common sense would tell you the gentler flame will vanish sooner, that the lesser heat will cool more quickly. But reality, once again, smiles at your assumptions and quietly rearranges the rules behind your back. Because under certain conditions hidden deep within the equations of thermodynamics and kinetic theory, the hotter gas can cool faster than its colder counterpart. The paradox is real, the contradiction is apparent, and yet the outcome is measurable. Welcome to the strange elegance of thermal physics, where intuition takes a back seat and energy tells its own story. Known as the Mpemba effect, this phenomenon, though long debated, suggests that under the right circumstances, hot water or gas can cool and even freeze more quickly than cooler equivalents. This isn't about magic or mystery for the sake of it. It's a lens into a deeper truth about how systems behave when driven far from equilibrium. When a hot gas cools, it does so with urgency. It radiates energy with ferocity. Molecules dance violently, colliding more often, emitting more thermal radiation, triggering convection and evaporation, altering pressure and stirring turbulence in their surroundings. The hot gas, like a heart freshly broken, doesn't cool gradually. It spills its intensity into the environment with a kind of desperation, reshaping the very air it touches. Meanwhile, the colder gas remains slower, more reserved. Its molecules, less eager to collide, less willing to give up what little heat they have left. And so the paradox unfolds. The one that burns brightest lets go the fastest. But this isn't just about temperature, it's about complexity. The pathways by which energy is shed are numerous and not all linear. When we say something cools, we imagine a steady march down a slope. But in nature, sometimes the route down is steeper for those who start higher up. In water, the Mpemba effect is enhanced by evaporation. Hotter water loses mass faster through steam, and with it, heat. It may also alter the structure of the liquid itself, breaking down hydrogen bonds, reducing viscosity, or influencing how convection currents develop within the volume. It changes itself in ways colder water cannot. It acts, it moves, it breaks, symmetry, and through that motion, it finds a faster path to stillness. This is the hidden poetry of physics, that sometimes intensity is the catalyst of release, that chaos breeds calm not despite its frenzy, but because of it. In astrophysics, this paradox finds echoes in the cooling of hot interstellar gas clouds. When these vast regions of ionized plasma radiate energy via X-rays, they do so much more efficiently than cooler gas regions. Hotter gas can more easily excite atoms into higher energy states, which then release photons as they return to equilibrium. The hotter it is, the more channels it has to lose heat. This is why clusters of galaxies, though filled with gas at millions of degrees, can cool rapidly, if the density is high enough. That very cooling can trigger collapse, form stars, birth galaxies. Heat, in this view, becomes not a barrier to transformation, but its herald. And the hotter the furnace, the more urgently it prepares the space for something new. This reverses the morale we often attach to intensity. We believe that the stronger the fire, the longer it lasts. That anger, passion, grief, when hot, must endure. But physics suggests otherwise. The most intense emotions may burn themselves out first. The sharpest flames may fall into silence before the embers even begin to stir. The paradox invites us to consider that heat is not only energy, it's potential for change. And potential, when fully realized, is no longer potential at all. It is release, stillness, equilibrium. What if the same principle applied to us? What if the moments when we feel the most overwhelmed by sorrow, by urgency, by desire, are not signs of permanence, but precursors to resolution? What if the heat we feel is the system shedding its surplus, violently but necessarily, preparing us for clarity? The Mpemba effect reminds us that the path to balance isn't always slow, that letting go might arrive with ferocity. That healing may sometimes come not through gentle unfolding, but through intense surrender. In our lives, we often fear the moments of peak heat, conflict, heartbreak, revelation. But perhaps those are the very moments that make equilibrium possible. By burning through inertia, by shaking the system, by triggering the cascade of change. In nature, cooling is rarely a straight line. It is a dance of mechanisms, a choreography of collisions, radiation, phase shifts. In us too, calm is not always the absence of heat, but the result of its fullest expression. We reach stillness not by avoiding fire, but by letting it pass through. Scientifically, the paradox continues to spark debate. Is the Mpemba effect real in all cases? What exact variables govern its emergence? Is it molecular alignment, convection, supercooling? A combination of several. Even now, researchers revisit the effect with better equipment, trying to strip away noise to isolate the variables. And though the phenomenon doesn't always appear, the idea it plants in our minds persists. That behavior at extremes often defies our assumptions, that the laws we hold close may fracture at the edges, that nature doesn't care for simplicity, it moves as it must, and that we must learn to read between the rules. The hotter gas cools faster because it can, because its intensity opens doors that cold cannot, because it doesn't hold back. It flings itself into the void, and the void, in turn, accepts it more completely. Perhaps this is why some people too burn brightly and vanish, why some moments of revelation come with fevered intensity, then leave us changed, cooled, quieted. The paradox reminds us, the end is not always slow, and neither is peace. So, next time you feel heat rising, in a system, in a soul, remember that what burns may be on its way to balance, that the flame does not last forever, that the hotter it is, the faster it may find the dark, the cool, the still. The moon is drifting away, and it affects time on Earth. Imagine you're standing on the shore at night, your feet buried in the cool sand, the ocean breathing in slow rhythm beside you, and above, in the ink-black sky, the moon, silent, watchful, immense, casts its pale silver light upon the water, a ghostly mirror of the sun, gently tugging at the tides with hands invisible but irresistible. It feels eternal, this relationship, as if the moon has always been there, always this size, always this distance away, quietly governing the seas and subtly influencing the rhythms of our bodies, our calendars, our sense of time. But this is an illusion, a still frame in a cosmic dance that has never stopped, because the moon is leaving us, slowly, silently, but surely. Each year, it drifts about 3.8 centimeters farther from Earth, like a companion edging toward the door, not in anger, not in haste, but with a certainty that cannot be reversed. And in doing so, it is reshaping the very fabric of time on our planet, stretching the days longer, rewriting the tempo of Earth's spin, and forcing us to reckon with a truth that feels more like myth than measurement. Time is not fixed. It bends to motion, it bows to gravity, it follows the moon. This drift is not new. It began billions of years ago, when the moon first formed, likely from a cataclysmic collision between a young Earth and a Mars-sized body named Theia. From the debris of that unimaginable impact, the moon coalesced, closer then than it is now, a colossal beacon hanging just 22,000 kilometers above the surface, nearly 20 times closer than today, looming in the sky like a second sun. Back then, it would have appeared 50 times larger, and it ruled more fiercely. Tides surged taller, nights were brighter, and Earth's spin, unshackled by the moon's break, raced forward, completing a full rotation in just 5 to 6 hours. Days were short, urgent, and quickened. But gravity, ever the quiet sculptor, began its work. The moon's gravity raised tides on Earth. Massive bulges of ocean pulled toward its position. And because Earth was spinning faster than the moon orbited, those tidal bulges lagged slightly ahead of the moon's path, like a leash pulled forward by the dog instead of the other way around. This imbalance created a torque, a tug that transferred angular momentum from the Earth's rotation into the moon's orbit, causing Earth to slow down and the moon to spiral outward. Slowly, day by day, the Earth's rotation decelerated, and the moon crept farther away. Over billions of years, this dance has continued, Earth sacrificing its spin to push the moon away. And as the moon retreats, Earth's days grow longer. Not metaphorically, but measurably. About 2 milliseconds per century are added to the length of a day due to this celestial withdrawal. It doesn't sound like much, but scale that up. 1.4 billion years ago, a day on Earth was just 18 hours long. If you could look into the deep past, you would see a planet spinning more quickly, a moon that dominated the sky, and tides that surged with force we no longer know. The rhythm of life was different, not just in behavior, but in structure. Circadian rhythms, biological clocks, evolutionary pressures, all shaped by the pace set by that moon and Earth's rapid spin. So when we say the moon affects time, we mean it literally. It stretches it, it slows it, it determines the length of our days, but it doesn't stop there. The moon stabilizes Earth's axial tilt. Without it, the planet would wobble wildly, over millions of years, possibly tilting as much as 85 degrees, turning the poles toward the sun and plunging the equator into long winter. With such instability, climate chaos would reign. Ice ages could arise from a mere tilt. Seasons would stretch or vanish. Ecosystems would fracture. Life as we know it might never have found its rhythm. So the moon's distance doesn't just govern our clocks. It underwrites the habitability of our planet. It's a cosmic metronome, setting the tempo for rotation, stability, and time. And still, it drifts. Still, it changes the pace. Still, it reminds us that nothing, no celestial partner, no relationship, is eternally fixed. The moon's retreat brings questions that reverberate far beyond astrophysics. What does it mean that time is elastic? That the length of a day isn't a constant, but a byproduct of gravitational negotiation? That the passage of hours we trust to mark our lives is, in truth, a shifting measure, governed not by certainty, but by cosmic motion? And deeper still, what does it mean that our perception of now, our human experience of enough time, or running out of time, is tethered to something that is quietly walking away from us? It reminds us that permanence is an illusion, that even the things which seem most stable, the moon in the sky, the tides on the shore, the rhythm of sunrise and sunset, are part of a greater unfolding. And in that unfolding, time is not merely passing, it is being remade. There is poetry here, but there is also precision. Scientists use lunar laser ranging, reflectors left on the moon by Apollo missions, to measure the moon's drift with millimeter accuracy. Every bounce of a laser beam across the vacuum of space is a reminder that even our closest neighbor is in motion. Even the constants are changing. Even gravity has a price. In the far future, this drift will continue. One day, perhaps 50 billion years from now, Earth and the moon will reach tidal locking. The moon will orbit the Earth in the same time Earth takes to rotate once. At that point, Earth's day will be 47 current Earth days long, and then the drift will stop. But long before that, the sun will have swollen into a red giant, swallowing the inner planets, possibly engulfing Earth entirely. The moon's story is moving toward an end we may never see. And still, its fingerprints will remain in the geology of tidal basins, in the fossilized growth rings of ancient corals, in the pulse of our calendars. Time, as we know it, is written by the moon. So when you look up at the night sky and see that luminous arc rising above the sea, know that you are not simply witnessing a light in the darkness. You are watching time itself, drifting, shaping, slowing, stretching, reminding you that even the heavens move on, and perhaps so must we. The faster you go, the heavier you become. Imagine a runner sprinting across an empty plain under a sky so wide it swallows your sense of direction, their legs pounding against the earth like drumbeats of defiance, their breath caught between urgency and silence, their bodies straining towards something unseen but deeply known, the need to go faster, to escape, to become motion itself. We admire speed as freedom, as momentum, as power, a force to be harnessed, a direction to be chosen. But physics whispers something stranger in our ear. something that rewrites not just our definitions of movement, but of existence itself. The faster you go, the heavier you become. It sounds like a contradiction. Shouldn't moving mean momentum, not mass? Shouldn't acceleration mean lightness, escape, a shedding of weight? But reality, again, cares little for what feels intuitive, because the universe, at its deepest level, is governed not by what we expect, but by what is measurable. According to Einstein's theory of special relativity, as an object approaches the speed of light, its relativistic mass increases, not metaphorically, but mathematically. What this means is that the very act of moving fast makes you harder to move even faster. It's as if the universe imposes a tax on speed, and that tax is mass. This isn't about gaining weight in the conventional sense. It's not as if a spaceship begins to swell with matter as it accelerates. Rather, it's a shift in the resistance the object presents to further acceleration. It's inertia. As velocity increases, so does the energy required to continue increasing that velocity. The closer you get to light speed, the more energy you need to add. And that energy doesn't just make you faster, it makes you heavier. Not in the gravitational sense, but in the relativistic sense. And at the speed of light, your mass becomes infinite, which is why nothing with mass can ever reach that speed. Light itself can only move at light speed because it has no rest mass. The rest of us, particles, ships, humans, stars, are bound by this cosmic speed limit not because we're not fast enough, but because the faster we go, the more we become. And the more we become, the harder it is to go further. Speed and mass, motion and matter. They are not separate stories but entwined scripts in the great narrative of physics. The relationship between them reveals something profound, that energy and mass are not just related, they are interchangeable. This is the core of Einstein's most famous equation, E=mc², which tells us that mass is frozen energy, and energy is active mass. And so, when we accelerate an object, we are adding energy to it. And that energy shows up as additional relativistic mass. The faster it moves, the more of itself it must carry. Think of it like a person climbing an invisible mountain. Each step upward, each increase in speed, adds more weight to the pack on their back. Not because they're picking anything up, but because the very act of climbing demands more energy, and that energy is mass in disguise. In the quantum world, we see this relationship reflected in particle accelerators, where electrons and protons are hurled at near light speeds, their mass increasing as they approach that unattainable boundary. It becomes harder and harder to push them just a little bit faster. It's not just technological limitation, it's fundamental reality. The universe resists extremes. It curves away from the infinite, and in doing so, it writes constraints into the heart of possibility. But what does it mean, philosophically, that motion brings weight, that speed adds burden? It suggests that there is a cost to escape velocity, not just in terms of fuel or effort, but in identity. The more you chase the horizon, the more of yourself you carry with you. The harder it becomes to outrun what you are. This is more than physics. It's metaphor made real. How often do we believe that going faster will make us lighter? In life, in ambition, in emotion? We sprint from problems, accelerate away from grief, speed through days hoping time will compress around us and deliver freedom. But the physics says otherwise. The faster you move, the more of your energy is converted into weight. You become heavier in your effort to be free. In that, there's a tragic beauty. A realization that maybe stillness isn't stagnation, and motion isn't always liberation. Maybe the journey forward is not about speed, but about understanding what we carry, and how that mass, that history, reshapes what's possible. This principle of relativistic mass isn't just about acceleration. It challenges the notion of identity at speed. At rest, you have a certain mass, your rest mass. But the moment you begin to move, especially at relativistic speeds, you gain additional properties. You are no longer just your rest self. You are kinetic, dynamic, bound to time in a different way. And as you approach light speed, time dilates. Distances shrink. Mass increases. Reality, in effect, bends around your motion. And yet, from your point of view, inside the moving frame, everything seems normal. This is the elegance of relativity. Every observer, no matter how fast they're going, believes they are still. It is only in relation to something else, some other frame of reference, that the distortions appear. And so we find ourselves once again at a philosophical precipice. If movement changes mass and perception defines motion, then identity itself is fluid. What you are is shaped by how you move and by whom you are compared to. This is not just about physics. It's about the self, about how our emotional mass increases as we accelerate through experiences, how carrying too many unresolved moments, too many responsibilities, too much forward momentum makes it harder to accelerate further. We grow heavy, not just with knowledge, but with velocity. Our stories, our ambitions, our expectations, all add weight to our being. And the faster we try to live, the more resistance we face. Not because we're wrong to seek motion, but because the universe balances effort with inertia. It teaches us to ask, how fast do you really need to go, and at what cost? In astrophysics, these principles play out on grand scales. Pulsars spinning hundreds of times per second, jets from quasars moving at near-light speeds, galaxies hurtling away from each other with relativistic velocities, all of them bound by the same truths: their mass, their momentum, their trajectories, governed not by whim, but by laws that shape both stars and souls. Even light itself, though massless, is touched by gravity, bending around massive objects like a whisper curling around a stone. And we, full of mass and motion, are shaped even more profoundly. The faster you go, the heavier you become. The more energy you pour into becoming faster, the more resistance the universe offers. It's not a punishment, it's a balance, a reminder that nothing is gained without cost, and no escape is free. So when we look at a spacecraft struggling to reach escape velocity, or a particle nearing the speed of light, or even a person racing through life at unsustainable pace, we are witnessing the same principle. That speed carries weight, that effort accumulates mass, that the pursuit of motion is not without consequence. And perhaps, in understanding that, we learn something deeper about what it means to move at all. Because if acceleration reshapes your mass, then every motion is a transformation. Every decision to move faster, to love harder, to work longer, to dream bigger, carries with it a hidden price. And knowing that doesn't mean we shouldn't move. It just means we should move with awareness, with intention, with the knowledge that speed is not freedom, it is gravity in disguise. The universe doesn't forbid speed. It just demands honesty. And in that demand, we find a different kind of truth. That you are not just what you are, but what you are becoming. And what you are becoming is heavier, richer, more real, because you dared to move.